hit start stream before I even had my mic plugged in. Hope you guys can hear me. How you all doing? My bad. All right. Let me know if the mic's actually working here. Hopefully it is. Okay, cool. Yeah, sometimes I do that. I get so eager to start the stream, I haven't even plugged in the mic. Okay. So today we are doing a kind of impromptu stream. I'm not streaming on Friday, and I wanted to talk about some of this stuff because it's been coming up in conversations, and I've been slowly making progress the last few weeks. This is why I haven't done a stream. I've got like 8 hack MDs since the last stream, where I've been working through design thought issues. Not all of them are related to concurrency and transitions, but I thought maybe take some time today to talk about the ones that are and kind of go and look at this topic again with refreshed eyes now that I have, the original context that I built this under, actually I guess the original context of when I saw from React, the context that I built this under originally was Solid 1.0 or before 1.0. I think the first version, I was just looking at this the other day. Let me see here. Sorry, let me share my screen. The first version of Solid that had transitions was version 0.15.0 that came on December 16, 2019. Been looking at this for a long time. And then obviously we did updates around the time of the 1.0 release. And then I haven't touched it since 1.2, I think, like very early on. And I've been redesigning it again for 2.0. But I mean, I shouldn't say I haven't touched it. We hit some interesting new use cases as we went into router actions and queries, like that whole area. So there's been a lot of thought, but not a lot of update on the core mechanism. So 2.0, I get to start over again. But I think before we even get into all of that context, we should really start with like, what is a transition? Why is it called a transition? All that kind of stuff. Might be a refresher for some of you, but I'm also banking on a lot of people haven't actually used these features in React, don't really understand why they exist. There's a lot of confusion. I mean, it's funny, people talk about confusion around RSCs, like React Server Components. Before that, there was confusion about the concurrent model, and it's a really powerful thing. And what it automates, removes a whole bunch of concerns that you'd otherwise have to deal with. But you have to also kind of respect the model, otherwise you'll be fighting against it the whole time. So I think we probably should start there. All right. Anyways, yes. Hello, everyone. As I said, I decided to do this stream today, mostly for my sake, because I just needed to kind of like talk through and like get some sanity around this stuff. You work on something too long, in a specific space, and then you're just like, you almost like develop your own micro language or your own like world, and it's kind of isolated from the real world. Yeah, sorry, Fuzzy. Yeah. So first of all, why transition? I honestly don't know why React initially went with that title. I have no insight into that. I picked it up originally because it was their call, like what they called it. So I was like trying to imitate, this concept. I didn't know what else to call it. It's unique. And I started going over different names, different titles, especially when I came into Solid 2.0, but then I kind of just went back to transition. See, the problem with transition is it conflicts with like view transitions or transition group or like animation type stuff. And while this feature can be related, it isn't that. Yeah, we're going to be doing some Excalibur today, most definitely, I think. Let me open that up because transitions are, for people who are not familiar with them, most similar to transactions, right? Most things that you do in reactive frameworks, and I don't just mean with signals, I mean with React, with whatever, um, you set some piece of state, and the guarantee is that everywhere, by the time you look at that state, has reflected that change. So like, you want to make sure it's consistent. You don't want someone to see, let's say you have two different data points that change or whatever. You don't want to see data A in its original state and B in its updated state. That would be called tearing, where you have like intermediate states, because there can be side effects, impacts of this, while it stabilizes, while it like kind of settles down. Like if you had to hit an endpoint or an API call based on two different pieces of state, and one updates and tells it to update, and then the other one updates and tells it to update. Well, you did two fetches when you could have just done one, right? Like if both changes are happening at the same time, you shouldn't ever create these diamonds or these fetching problems. And we've talked about that a ton on stream. But the challenge is these guarantees can only really be made synchronously. Like when like once something goes async, you no longer can know, because it's not like you're going to have that first fetch wait indefinitely. It doesn't know that it needs to wait. So for that reason, we enter a zone where there's like what I call the three different modes of what you can do when you hit async in general. And what I talk about this is with signals, we talk about this, but it's funny, React's use hook has similar semantics in that it's read based rather than write based. And what I mean by that is it isn't the fact that you're fetching data that causes your component, like it is why your component suspends or it throws or whatever, but it's not the point at which you do the fetching that matters. It's the point at which you consume it that matters, because that's the point where you can't render the UI. That's the point where you can't show the piece that you need to show. If something errors with your async data, yes, you can handle it where you do the fetching, and you could if you doing retry logic. But if you fetch something and no one is listening for it or using it, then the UI can render perfectly fine. So that is kind of the kind of mentality that we've been looking at a lot with async, which is actually turning it into a graph, essentially a dependency graph, just like in typical reactivity. So let me take a look here, and it's funny because I probably made this list before on stream, but we'll do it again. When you have async, there's three things you can do when you hit something that can't render, right? You can pair, which is usually the default in most systems. What I mean by that is pretend you have a user ID, and whenever it changes, you fetch a user. You can show and the first thing you do when you want to fetch the next user, you're going to the next tab, you're cycling through the users in a modal or photos or whatever, is show the updated ID, because you need to update the ID to go fetch the user, but you're still going to be looking at the old user for a moment. So this is called tearing. So this is updated sync state, stale async state. Okay. Can you all see this? Maybe I should make this a little bit bigger. Let me change my text size here. This should be extra large. Yeah, whatever. I'll make the whole thing extra large. I don't really care. Let's move this farther up. Okay. Next. So we've all seen this. From a framework standpoint, this is generally undesirable, but there are cases where this is, acceptable. Like what if you're doing like a autocomplete search on the page? Like you're okay if you can like type ahead and like do stuff and have things working in the background. You don't need it all to stay perfectly in sync. The input field does not need to reflect the results that you currently see on the page. You're allowed to type extra characters and be searching and stuff. So tearing is fine for a lot of stuff, and it's what we're accustomed to, because one of the cool things that tearing has that I'm going to add a little sub note here is affordances or staleness are sort of built in. What I mean by that is, I said sort of, but they're built in, because when you see the updated sync state, like it's not that the affordances are built in. Sure, that's not quite the right wording. It's more that like immediate feedback is the best way to put it. There's immediate feedback because the second you click the tab or change the ID, you'll see the updated ID or see the updated tab. So the user knows that the button click worked. The problem is you're showing them like some kind of half and half state, which again, for the UI, lowers confidence. And I mean, for background processes can be detrimental, right? But there's immediate feedback. Person doesn't think your app's hung. The second state of the universe is what we see a lot with suspense, which I call is bailout, which is basically show nothing or something else, right? The idea here is like stuff like suspense is an example of this. Await components in Svelte or whatever. Like, I mean, or at least classically, I know they have a new async model. We could probably talk a little bit about that as it comes up. But my point is, yeah, I'll talk a little bit about DaVinci a bit later and the updates on Start. Yeah, so what I'm talking about here is like show a fallback. But it's important to understand that what's beautiful about this is it's actually we can add some more notes here while we're in here, right? Because this one has immediate feedback, but inconsistent. This one also has immediate feedback because, and it is consistent because it doesn't show anything. So like the second something goes loading, you suddenly see a fallback, right? But I will say, incredibly jarring when you already have data, right? So what I mean by that, I mean, I think everyone's seen this. I'm just gonna do solid.js.com. I'm sorry for people who already know all this stuff to start with the basics. I just want people to understand the language that I'm using when I talk about this stuff. But if I could go into the transition example, but don't do it with transitions. Every time I switch, you see some kind of loading indicator, right? This is fine, but picture if you're on a page and you're doing like a type ahead. As I said, there's different types of scenarios you can think about. It'd be very brutal if the whole thing just kept on, like every time you type a character, it would like unmounted and then showed loading. And this is really easy to do with suspense. This is the kind of thing that makes people go kind of nuts with it. Right. Which I'll get to in a minute. So sorry, where's my scala draw? Yeah. So challenge drawing when you already have the data. Yeah. So yeah, and you get these like intermediate states. Suspense is good at bundling them together. So instead of having like 20 spinners, you have one. You know what I mean? But this is don't get me wrong. All these patterns are they're not bad. They fit different kinds of use cases, right? Okay, let's go down to number 3, which was just suggested in chat, which is hold in the past. Show the current until the new is ready. This one, the challenge here with this one is because you're like, okay, well, this should be the default, but check it out. You said to yourself, I'd rather if something loads fast enough, not to bother showing empty state, just keep loading. If it loads fast enough is the key. Because this, no immediate feedback automatically. Like these ones are automatic because the thing just unmounts. This thing, the sync state will update, so you'll see it. But this one has no immediate feedback, which makes it very awkward to have as like a default, because if something is not fast, then, well, you have no affordances. People think your app hangs. And this is something that we've hit in Solid Router, right? Because if people don't use is routing signal, like the thing to say that, hey, I'm pending, then they don't get any affordance, right? Like I'll go back in this transition example and I'll solve it. And see, in this example, I've added like this nice little fade out with a delay on the CSS. So if it happens fast enough like that, you don't even see a change. But if it takes longer, I mean, I could probably adjust this example to take, is there a way I can make the promise take longer? Yeah, let's make it like 1,000, yeah. See that, like how it grays out? But now picture if I didn't add this, what is it called? Where is it? Classless selected, tab, where is it? Pending. Yeah, if I didn't use the pending. See, in here we have use transition pending. If I didn't put this pending state in here and I just said pending false all the time, what's going to happen is when I switch, I'm going to click and be like, what's happening? The router is really, really slow. I click on it, you know, and there's this delay. Click. Okay, that one was fast, but click. And suddenly you write an issue on GitHub that Solid Router is really slow. It's waiting for the data, but you have no affordance. There's no immediate feedback here. I think this is, yeah, sorry. This is the one that actually makes it longer. I put I made the other one variable. Should have been like this. Yeah, there we go. Now it will, you're like sitting there waiting for the page to load, and then, right? Right. I mean, my preference is the old state, but make it obvious the old state is shown. And if it loads fast enough, but still slow enough for me to see the loading state for a bit, keep pretending it's loading for just a bit more. Yeah. I think the thing is, people, this is a great comment because you're actually asking for the page to load longer here. But the irony is, and this is why, you know, one of the reasons that I was really into transitions, because this is what we're showing here is transition behavior, holding the past. And I'll explain why I use transitions in a minute. But is most people, and then when you add, I mean, let's go back to our original example with the transitions. I remember I took this into my office workplace and I first showed them this, right? Or sorry, no, let's reset it. I first showed them this. I showed them this experience. Right? And then I showed them this experience. And most people told me that they thought the second experience here was faster. Right? Like I could be a little less aggressive on the fade out delay on this timeout. Like if I delay it, let's say 0.2. Yeah, exactly. There, I delayed it long enough that, like, I did this one shorter so you could be more visual, but most people said this looked faster. They thought it was faster. Right? So, like, you can, in theory, even make it take longer to load as long as you do it in a certain way. People will feel that the loading is faster. I'm not suggesting necessarily make your page loader, but in general, delaying the pending state on transitions is often a good thing, just a little bit, because people have a certain threshold, I think between 200 and 400 milliseconds, where they're like okay for it taking a while. So if you don't show the loading state during that time period, you're actually okay. Yeah, right. Exactly. So there are proven UX reasons why people want this sort of behavior, right? Um, and this is why this is hard to do, or why this transition we'll talk about in a minute. But there is actually a fourth option we don't talk about very often, which is, you know, a pretty powerful option: predict the future. Um, so if you know what the good old reason why people add mirrors to elevators, interesting. Yeah. So what do I mean by predict the future? Um, well, if you know what's going to happen, you can kind of fake it. So this is stuff like temporarily add next state. This is things like optimistic updates. What's nice about this is immediate feedback, consistent. Can't always do this because you don't know what the impact is of what you're going to do. Do you know what I mean? Like, sure, like if you're doing a mutation, you know what data you're saving. You could pretend that data is already in this data set. But if you're just like saying, I need to refresh the data on my page or get the next user, you don't know what that user looks like always. I think from a pure UI standpoint, an example of this is when people like stub out, but like there's a lot of similarities. Like when does this become this bailout, right? Because if you could just make more realistic looking uh placeholders essentially, right? Because in a sense, predict the future is putting in a placeholder. So arguably, maybe this is like not an actual. It's like just a version of two. Because look at the characteristics: immediate feedback, consistent. Instead of being incredibly jarring, this one can't always do this. Do you see what I'm saying? Like they're basically the opposites of each other. Like they basically, if you bail out, it's jarring. If you can predict the future, it's less jarring, right? But they actually have the exact same characteristics between 4 and 2. So I don't know if 4 is actually, if we should just categorize it under 2. But for me, when dealing with async, there are really these 4 options, pretty much. Okay. So everyone chat still with me, right? One is easy to do. Right. If the funny thing is, it's like even easier to do with something like signals than like top-down VDOM render, because literally you can just be like render something and do like a conditional, and then when the signal triggers, it doesn't rerun the components. It just like literally goes from where the like the control flow is and continues on. But you can still do this in React or any framework. It's very easy because it's once you have like an ID or something in place, like I think we've all written probably, I mean, I go on the playground right now, but we've all written this code before, right? Where you have something that's like, I mean, I'm going to use solid as an example, but you have something where it's like show when uh, data, or let's say user. Everyone's seen this, right? Show when user. For you all who aren't familiar with solid, I think you can still figure out what this component does. And then like inside, you can be something along the lines of like, I don't know, you're showing something with the user information, right? You're like div. Don't get me on my CSS here, but you're like div user dot name or something, right? Once this is true, and like then this is always going to be true. Like even if you have like some lovely code up here that's like const ID set ID. I mean, it could be from a props, but I'm just doing this for fun here. We can just go like ID equals 1 and then be like, I mean, let's do this the old fashioned way. Create effect. I don't even need to use create effect. Actually, it's solid. Oh, actually, I do because I want to react to the thing. Okay, so if we did something like this, where we're like, so I could use an async function and add cancellation. Let ignore race conditions and cancellation for a second. But like if we did something like fetch user ID, then set ID, or actually, sorry, then user set user, right? This is like the most kind of dumb way of doing async. What my point is, you can see this directly from this code, hopefully, is initially user is undefined. So when it goes show user, it's false. And then, which means it doesn't do this. And then, but it runs the effect on the ID, fetches it, and then once it sets the user, it continues from here and then does a username. But when you set the next ID, when you increment it to ID 2, what ends up happening is show user is still true because you have user 1 already here. So then it fetches, and then it shows. But if we had somewhere also in the UI something like this, where we're like div. Now, if you're smart here, you know, you would just go user, you just use user.id and people would know that it's the same user and like it would update with it. But you don't always get to do that. Like, let's say it's tied to something, a different component somewhere else, you know, being used. If you used ID here, what you would see, I mean, we could just do this right now just for the sake of showing off this demo. I mean, let's just implement our function fetch user ID, return new promise, resolve, set timeout, res. Then we'll have to make something up, which is like ID name, whatever. I don't really care. And give it 1 second timeout. Import create effect as well. Create effect. ID is a number, hopefully. And let's import. Is it show? Okay, and then all we need to do here is add a button. I'll put the button in here too. It doesn't have to be, obviously. In other situations, the button would be problematic if it was in here. But for the, let's increment it, and then on click. Set ID +1. Okay, right. See, caring, right? ID updates. I mean, I can make this more clear. Right. This is kind of like the default, you know what I mean? All right. Yeah, so you can click it like 5 times and then this is because these are set times, but if we wanted to make real chaos, I would make this last number random, and then you would see all sorts of problems in race conditions here. So, I mean, right off the bat, I mean, we see problems with the naive solution, but there's ways to fix this naive solution. One of the ways is using dedicated data fetching primitives, stuff like React Query, stuff like solids resources or create async. These will deal with weird race conditions, right? So that, but in general, there are cases where this is not desirable, is all I'm trying to get at, right? Let's go back here, right? Immediate feedback though, right? I click this thing. The second I click it, that updates. I know something's happened. So that's easy to do. This is also easy to do, the bailout, right? I mean, forget about nesting and suspense and all the cool stuff. All you have to do is essentially add some kind of loading state conception, because if we add another signal here and go const is loading, set loading, right? And we can say initially loading is false. It doesn't really matter. It's going to load right away anyways. So then we go here, set loading, true. And again, we're not handling race conditions. We're not handling all the other fun stuff that comes from this. I know I'm glazing over this stuff, but that part is actually handled pretty well by most frameworks these days, as long as you're not using use effect, as long as you're using, I guess React doesn't ship with it exactly. I mean, they have server components that handle this, but like it's so, I haven't used use effect the data fetch for ever, because we introduced basically something like a very basic version of query in Solid back in 2019, 18, like right at the beginning. I was just like, this is so many places to screw up. But all we have to do here is we wrap the loading state, and then you go when not is loading, and there's a user, then we'll show this. And then obviously now we can't, we need a fallback so that we can actually see that it's loading, so that when we click it, there we go, loading. I mean, this isn't suspense. This is way simpler than suspense, but you get the idea, right? And this is where I was talking about where the button might actually be on the inside, might get on it. Let's do a fragment here. Okay. Now what we can do is we can keep the button here. My CSS is just terrible. I'm like, just to be lazy, I'm just going to do this just so I don't have to deal with just changing the inline. Yeah, there we go. Oh, okay. So my point is, I can hit it like 5 times. Oh, look, this actually screwed up because of it. This doesn't handle race conditions. It's not keeping a counter. This is why I wanted to show again just how many places naive data fetching falls apart. Because if you have multiple concurrent ones, this loading can't be true. It actually has to be a counter. So then you have to, like, change this to 0, and then change this to C -1. And even this won't handle stuff coming out of order. This will just make this this particularly perfectly symmetrical time example probably work when I click it like 5 times. Yeah. But it's kind of crazy that when you use frameworks, you have to manage this stuff. As I said, I'm not even using random return times, right? Because otherwise that would throw a freaking wrench in everything. But Well, the reason I want to show it this way instead of using suspense or like transitions and type stuff is that these are general concepts. This is like physics. This is like truth of the universe of how you can handle these situations. There's not like, this is not framework specific. This is just reality, right? Suspense is an example of this, but you can do it manually, like I just showed. Suspense is powerful because it does a, what do you call it? Like the thing, I forget the programming term for it when you inversion of control. Yeah, inversion of control. Suspense basically lets the children decide the situation. Okay. So let's continue. Let's talk about hold in the past. The reason hold in the past is so hard is this situation. Now, I'm going to get rid of the loading for a second because now we're back to like not doing the loading, right? I mean, we might still need to know about loading, but it's not going to be dictating whether we show stuff. So I'm going to leave the loading for now and see if we need it for something like in a minute. But if we wanted to hold in the past, our problem here. Now, obviously, I could use user.id, but that's not a fair testimony of holding in the past, right? The way you hold in the past, yeah, I probably don't need loading for this example. The way you hold in the past in the naive way would be to go const next ID set next ID equals create signal, and we'll start at 1 here as well. Okay. And then the problem is you need to update the thing here in order to fetch the data, but then you don't want it to update here. So what you have to do is essentially, just conceptually, if you make it next ID here, and then when you click, you set next ID, and then when you finish the fetch, you go set ID to, ID. Or actually, a better way to do this would be, more correct way would be const ID equals next ID. So you want to grab the one that you fetched with. You don't want to like read it at that point and then set it like this, right? There we go. There we go. And if I click it 5 times, that's fine because it makes sense. We're not, but you understand that this actually has the race condition problem. When you see stuff like that, you know that potentially if these took variable different timings. So if you could solve the race condition problem, like with your base primitives, like don't use create effective data fetch, use, a data fetching primitive, then this would, basically when you click it 5 times, it would recognize that and then it would jump from 10 to 14, right? But my point is, this is how you do it. And it's not hard to do. What we did was we took the state and then we forked it. We created a different version of that state and said, look, we're going to use that different version to fetch. So we're going to set it ahead and then we're going to do our thing. And then we're going to update the synchronous graph at the end. So everything is consistent at the end, and kind of like shift it through. Now, if other things derived from ID or next ID, then you need to pull them out and fork them as well, because basically every part of the chain that happens before the data fetching needs to not apply until the data fetching is done. Right? This is very important because this is like an on write consideration. It's not on read. We were talking about on read because we were worrying about like, can we show the UI? But what this means is up until the point of async, right? Every data propagation can't be committed until the async is done if you want to have this consistency. Otherwise, something's going to leak. Something else that depends on it's going to show up on the UI or show up somewhere else. So it's not as simple. I mean, it's fine if you control everything. Let's say you own the router, right? Conceptually, if this ID is your location, and then this is your next location, you know everything that you need for the next location, the data fetching, all that stuff. You control that all within inside your system. You could build a whole system out that reads off next ID based on your internals, and then at the end expose to the user maybe this ID stuff. Well, I mean, it's a little trickier than that, right? What if the user has to use your location somewhere deep in their component tree? They need the updated location when it's rendering the next page, but then you at some point you're gonna switch it back on them. Like, do you re-render the page again? Like from React standpoint, or like how do I swap it from listening to next ID to normal ID, like from a reactive standpoint? Like, let's say I build the next page all using next ID, right? And then at some point it has to become the ID so that when the next page comes, it doesn't immediately change because it's the next ID. Like, this is very easy to understand from a reactive graph standpoint, because you literally made the dependencies against this signal, not this signal, which means that the following one, it's still going against this signal. You want to almost swap the signals to go back from next ID to the generic ID so that the next page can render off screen and you can keep this one fine where it is. But let's pretend we're not using signals. Let's pretend we're using React. Well, if we're using React, it's almost like we have to render the page again, because there's this like kind of weird awkwardness here. Split context, so the fork has the next location, that's the URL bar, and the previous view has the later location. Yes, but then at the end, you have to reconcile that so that the next becomes the current, so that then it doesn't get changed when the next happens. And you'll still want it loading affordance. This was the problem here, right? No immediate feedback automatically, right? So you're right. I took out the loading affordance, but realistically, you're right. Sorry, let's add it back in. Is loading, set loading, because yeah, it actually didn't remove the need for the loading affordance, really, because now what we actually want to do is we want to do it in a different way. We have to go set loading true. Doesn't really matter. Set loading false. And then we don't want it to yank it out because that defeats the whole point of keeping the pass. But we might do something like, so we don't have this fallback loading, but we might do something like, whatever. I'll just do a div. You know me, div soup. Something like is loading Actually, I can just do this, I think. Oh, right. It's because there's no initial. You see, there's actually two different loading states. I got rid of it. If I put the fallback here, fallback loading, it's a different loading. This is like the initial loading thing, and then this is like this race conditions again, but you get the idea, right? Because this way you can hold in the pass while giving the indicator. This is the like graying it out thing, where the fallback is like the suspense, right? So we're actually talking about multiple affordances. This is why. This is one of the reasons why you can't just default to number 2, right? Very easily. Like, where does this come from? Like, some people, or sorry, I say people, but some frameworks kind of been working on approaches where they can do something, sorry, default to number 3 here. Some frameworks have been working about injecting this kind of loading state through like components, so that like it kind of holds and then doing that. But the problem is, and you can see this here, is conceptually, you could do this at a component level, but it's very, very restrictive, right? Because this is transitions are actually global, right? They're above the suspense. It's everything before the async that matters that you have to fork. So the second you make the transition about the components and try and localize it, you can immediately break that by making a change higher up. So like, it's not the right mechanism for holding to just say like, oh, I hold at component level. It actually doesn't make sense, because this is on a write. It's where the write matters. Components are about the read. So like, this is a hard problem. There's I'm hoping you're starting to understand why frameworks have built-in async primitives. I mean, React doesn't really, but I mean, use is verging on it. And I mean, it's why they push server components, because it handles this stuff. Because like streaming in this can also be handled if you have the primitives, and you can actually inform stuff like SSR and stuff. But it's also why transitions are not simple to bypass. Sorry, the same context key, but the fork has this next value. So when it swaps in, there's nothing to update. So like, yeah, I see what you're saying. Like, you keep the signal references the same, but then like you swap, you just keep on creating the next thing, and like you swap the pointer to what is next, essentially. So you build the next tree with the graph, and then the code that like will build the next tree will create new signals, and they become the next tree, and so on. So you switch the pointer basically to the section of the graph, so it doesn't have to actually update. It stays fixed on the same thing. Yeah. That being said, that only really works, as I was saying, is in a situation where you can control the fork state. So like, if you control the router, and you can be like, look, the router has this capability specifically. It's not a generic mechanism. You know what I mean? Like, you can be like, I know everything that is going to derive off it, and I'm the one who's actually supplying that to my downstream, to like my downstream things, right? In that scenario, you can build a very like, you can contain the solution specifically. Yep. I mean, yeah. Actually, I like this. You're right. You're right. This will actually help a bit with our state synchronization problem here. Let's see, where did I put it? Is loading. And for people who've used React, this is actually beautiful, because yeah, React is useless without. Yeah, that's true. Use can't be used on its own. Yeah, that's a good point. Yeah, because use memo isn't guaranteed not to rerun again. Yeah, no, for sure. The reason I like this solution is this is what is it? Use deferred value, essentially. Like, now when I do this and I click it 5 times, it doesn't solve all the race conditions, but the loading state actually is proper, right? This is like a really simple version of use deferred value, right? Because you have the ID and the next ID, right? Like the kind of forked versions of the IDs. So yeah, this is kind of where a lot of complexity comes in, right? Because either you manually fork it and maintain the swaps of context, right, in a contained scope, or you do a general solution, right? The general solution is complicated, so I can understand why someone would want to step back from it. But I'm just saying, like, there's problems we have to solve here, right? there's race conditions in terms of the fetch. There's if we want to be able to do this kind of holding ability, we need to know exactly what's forked and contain that and handle the context switching. Like even with these simple examples that I'm showing here, they're not foolproof. You actually have to do more work. Which, okay. I'm hoping I've at least shown the general concept here and made a case for why these solutions exist, right? I'm not talking about, it's funny because when people talk about concurrent rendering in React, they talk about, time slicing and all that stuff. I don't care about time slicing demos. Honestly, I shared a clip up on Twitter a little while ago, but Aiden from Million and me had the very best time comparing Million to React Fiber time slicing, and it was such a great example or demo of things because I wish I actually had the demo still in front of me. I mean, I could pull up the clip from Aiden's stream, but like, I mean, let me see if I can find it. Like, YouTube. Let's go. Was it live? When I want to kind of, let's see, Aiden Million JS. There should be like a block VDOM, yeah. Yeah, I'm gonna play this clip for a minute just to refresh people on this topic, because I can't emphasize this fact enough. Okay, I'm gonna change how I present. I'm gonna remove this for a second. Present. Chrome tab. Yeah, here we go. Let's do this. This little clip is just great.
Like an example like this seem even smoother. You care, but you can click the little and let's. So when you say React versus Fiber, is this 15 versus 16 or something else special?
It's using the same version, but Fiber uses start transition.
Okay, good. So we'll see concurrent rendering. All right. Is this the idea that I'm supposed to do this like really, really fast?
You might need to put up the node count, so there's some more effects.
Okay.
Yeah.
All right. So I can add a 0. I can go like this.
I love this. I'm getting ads on my own channel. That's hilarious. It's.
Before you leave, can you turn that document into a PDF for me? Thanks.
I did it. I killed it. Okay, fine. Let's meet in the middle. 5,000?
Yeah. There we go.
I first want to say these examples are for concurrency are always so dumb, because in order to actually do anything with them, you have to actually like pump the number of nodes out to some stupid amount that it's like pushing the CPU. And so it's kind of like, anyways.
Let's just
paint
it red. Okay.
I don't know if people notice this, but every time I press the button on the stream, I actually lift my hand to try and show like the delay, but my hands even has a bit of delay on it, right?
It's better. This is the example I wanted. Thank you. This is exactly, you can see start transition already kind of making it. The big thing about start transition is I love this example because it shows it. Look, when I click this on React, there's going to be a delay, right? When I go to Fiber or concurrent rendering, there's still going to be a delay, because even if it can schedule the stuff so it's non-blocking and keeps on spinning, it can't make the work happen any faster, right? Let's try million.
I really hope this works.
It does.
Okay.
And
Yeah.
there's less, but here's the difference. There's less delay. This is the fundamental difference.
Right? Like I'm not talking about the latency here on this spinner thing. I'm talking about between me clicking the button and seeing an update on the screen. I click the button, concurrent React made it so that the spinner doesn't die, like the animation doesn't die, but there's a delay between me clicking the button and seeing the 15 or the 16 or the next number. Million, the spinner might chug a little bit, but there's no delay on there's almost no delay on my response here. And the original React is just like delay and chugs the like kills the animation.
Do you see? There's less delay here. I'm like trying to raise my hand so people can see the delay. Like even I go to Fiverr, which has the same looking graph. To be fair, like it doesn't delay it that much. Like it doesn't like trail that much. There's a delay, like.
Which is the whole thing is that concurrent rendering doesn't improve performance, right? Like this is why it like it still has to do the same amount of work. It just does the work off screen and lower prioritizes it so it doesn't affect what's on screen. So like there's benefits to it, but it doesn't actually make it faster. Right. I mean, the idea here is that you're supposed to assume that this thing that you're incrementing is less important, which makes these demos terrible because usually the thing you're interacting with is the important thing. Right. So these demos are like sometimes backwards. I think that's why the Kaspersky's triangle example was used a lot because they tried to prioritize the animation and the clicking and hover over the numbers updating inside, which is actually more like an animation facet. So it like there's a conflict here, right? Like, which is kind of funny is that the thing you're interacting with, you probably actually want the speedy response on, not all like the background updates and animations, but the background updates and animations are the things that make your app appear sluggish, like noticeably, right? So Fiverr and concurrency from a performance standpoint is great in that it makes the app not appear as sluggish because the animations are smooth. And I mean, I remember doing this in React Native, not like concurrency, but the fact that like you did a lot of like work to try and make it seem smooth, even if the total output was slower. We talked about this earlier. It's the optical illusion of performance that matters with transitions, right? Because the things that you end up smoothing out it's usually like the opposite. Like it's like the background, like the thing you're actually interacting with is the thing you actually end up slowing down from like a total time period, but you make the whole app feel like it's smoother. So in a sense, it has a positive UX gain, but it doesn't have a performance gain. Okay, so I'm hoping I've made that part of this at least somewhat clear. Okay, so I think what translates to Git branches to create new branch, you need to fork one commit to build that. Yeah, I mean, my stream cover today was Git. Whenever I talk about concurrent transitions, I use Git as like my image for it because especially when doing concurrency in reactive libraries, like things with signals, it is way more like Git. But let's get there. Sorry, pun. Anyway. I think I'm hoping that I've established what transitions are, why they're important, and what they're not. When you're looking at these async problems. So let's see where to go to next. There's been some good discussion on Twitter. LLM framework stuff, Ryan Florence. I'll worry about that later. Because I do have some. Oh yeah, we can talk about actions. Do I want to talk about actions yet? Yeah, it's one of the big topics here. I think actions is what we should talk about. But before that, all right, because actions, I'm just trying to like think of the order here. Let me just pull up my HackMD right now because I. Oh, it's been that long. Give me a second. This is what happens when I don't stream in 3 weeks. You can tell that I don't do most of my work on this computer. All right, we're in. Yeah, so since last stream, I've written 1, 2, 3, 4, 5, 6, 7, 8 HackMDs. But most of them are. I did a couple about firewalls and derived state. I don't think I'm going to get into today. If it's safe to write to single and derived computation, VDOM as a proxy, non-reactive effects, dynamic optimized. Yeah, so half of these are actually about other design considerations. Let's see if this is a good place to start. Yeah, so let's just get into how one would design transitions. And I will publish this one out here. Publish. Copy link. I'll put it in here in the chat. All right. So I've kind of shown how we could mechanically do it manually, but how would we approach actually designing a solution like this? The way React works generally on this is they literally just fork the component tree from that location, like from that state change. So state change tied to components in React. So you know whatever you call set like with inside the transition API, whatever you state change you call, it's going to basically go, okay, from these components down, they're going to be part of a transition. Then it basically renders them off screen, collects all the async, all the use places. There might be places where it has to stop and re-render, because it throws, component stuff. But generally, it just kind of works its way down through that tree, re-rendering everything top down as it hits stuff and moves through. And then when it's done, it will say, look, this is the new VDOM tree, diff it against what's there, and show the updated UI. That's how I would summarize transitions, in React. And I mean, I could write that down if that helps people visualize it, right? No, I didn't want to move that. I wanted to move me. Yeah, let's move me. Yeah, let's do this. I mean, this is a grand oversimplification here, but generally transitions in React is like capture state, i.e. components that update inside transition. Defer until like defer to later, basically a render of these components off screen. Yeah, and actually, I want to take a moment to stop here because some people think that they solve transitions almost the way that we solve some stuff in animations. It's that like it's possible to hold values in the past sometimes by just keeping a reference to the DOM nodes and unhooking them from the reactivity system, right? And so like if you basically said, okay, I'm going to say freeze what I have there and then do update these states. So now the UI is not updating, fetch the thing on the next, page and then swap it in. That kind of visually might give you something that looks a bit like transitions. But it is not quite the goal here because you don't know how long that async is. You don't necessarily want to freeze everything, right? And I told you it's about right. It's global, right? It's not, you can't just, you can try and compartmentalize it, but then the second you have to go higher, you have to reformat that boundary, so to speak. It doesn't make sense to make transitions local. It's a write mechanism, not a read mechanism. So like, because of that, most proofs that transitions work involve having a counter on the page or a spinner on the page or something that's constantly updating while under the transition, because you have to show that both the future state exists and the past state is still updating at the same time. Yeah. It moves it reactive, which is not great because users sometimes change their mind when navigating. Yeah, for example. Yeah, that's a great example. Navigating, you click and then you go to click again, and no, sorry, we've detached the thing. Now, if it's an anchor tag, the browser might try and do its own kind of navigation. You know what I mean? Like do a full page navigation. But let's pretend we're using buttons or something. Like basically any action, you're allowed to like the page you need to be able to keep this stuff interactive. Otherwise, it doesn't really work properly. And I want to. This is why it's important to understand. It's not simple enough to just go, okay, well, this is the new branch. Keep on showing the old one, but kill it. Like that doesn't actually solve the problem. So yeah. So when the state, so capture state components that update inside the transition, which also involves like some sort of forking. I don't know how React does it or when exactly they do it, but you have to understand that the state that you write, like see, React always writes state in such a way that when you say set state, you look at the next line, you don't see the state update. So the transitions don't seem actually that jarring from that perspective. And it's kind of like you don't know when that state applies. So React has some kind of like, I don't know if they have to do forking at this point or how they manage that, but basically like don't apply the pending state. Right? Capture the state that changes and update string, but don't apply the pending state. And in React, it's pretty straightforward because, again, there's no expectation of you seeing it during the synchronous execution anyways. But they have to know, like, don't apply it until defer a render of these components off screen, right? Collect promises, via use or whatever. Rerun render as promises complete. So this is like go to 2. You know what I mean? Like basically you do this loop while it's collecting promises rendered properly. This is why caching or like it's awkward because use memo isn't always enough. Like you need a way to make sure that like if you're fetching in the tree, you're not refetching and restarting this infinite loop over and over again. And then finally, when no more promises, diff patch tree, right? Diff patch live tree. Okay. Yeah. Main tree, whatever. Yeah, let's say main tree. Now, a couple details that are important here is it's funny because React, when they first came out, they wanted to do multi transitions, but technically, I told you solid release in December. We actually released our transition feature before React did. I was so sold when I saw those original demos. I didn't care about time slicing because people were like, oh yeah, this will solve React's performance. I mean, by now at the time people didn't know, but by now people know that when React says they're going to solve the performance problem, they're not talking about the performance problem you think they're talking about. They're talking about the performance problem of having 1,000 developers working on a project and doing really dumb stuff. They're not talking about making the framework at all faster. But everyone was like really stoked on that aspect of it. That was the least important part about this. As we showed, the performance is not even really something I'd be considering too much for most people, right? But the UX automation aspects of this, to remove the tearing, it's actually quite nice. So for that reason, what I was having some trouble when I was working through this and making it work right. I made a decision. I was like, how many features do we need? So I decided to make one feature in that December 19th 2019 release. I was like, let's do one feature. And React was advertising how they had all these multiple features. They had these really cool experimental docs that I used as a baseline to understand the behavior. They're not up anymore, but they basically showed suspense, transition, all the stuff. They kind of like the blueprint. Even back then, I was talking to Ricky the other day for the React core team, and he was like, Suspense always did this. And I'm like, no, not in your original docs. Like there was actually like a version of Suspense where transitions held even with new suspense boundaries under it and stuff. They actually shifted and changed the stuff during the experimental phase, which is fine. They made some really smart decisions there. But the point is, about, I guess, 6 months later, React Core, or when was it? Was it in 2020? I guess. Like I remember around the time that the React released the transition stuff under the hood. Maybe it was a year and a half later. I can't remember. They actually came out and like, we are doing single feature too. What does single feature mean? That means that there's only really one transition in the app and that concur at the same time. So like it only creates one. Yeah, back in the day when Suspense had a built-in timeout. Yeah, exactly. Yeah, that was the old version, because people like the original thinking was like, or there's like a global suspicion timeout. Like the original thinking was that like maybe it would be okay if, or that transitions should bail out after a while and fall back to Suspense if they take too long, right? Because again, there's no affordances for holding in the past, right? And it's hard to say like this is our default API when you have an affordance to hold in the past. You could, if you set it like a default timeout that says, look, after 3 seconds we're going back to fallback if it's not ready or whatever, then like people couldn't shoot themselves in the foot too badly. Like you still probably want a pending indicator, but if you said like, after a certain period of time, like, sorry, it's going to go back to fallback anyways, you're basically adding back affordances for loading without people having to be forced to add loading performance affordances. As I was saying here, you get to an interesting place when you have both, say, Suspense and loading affordances for transitions, right? Where you essentially have two different loading affordances. And I've struggled with this from design perspective over time, because there really are two different things, right? So like, 'cause sometimes like there's the stuff that's local to what you're doing, right? Which, Suspense can act as a version of it, or maybe, like your typical loading indicator, like, while you're doing something. But like when you're navigating to the next page, it's not localized. You're actually saying, you're showing a loading indicator indicating that you're going to the next place, but the thing that's loading isn't the thing that's in front of you. It's the thing that's off screen, which means that the mechanism for loading indicators for things around transitions isn't localized generally. And it makes sense because, again, transitions aren't localized, right? Like, they don't have to apply to, like, where they affect the UI might not be everywhere, but conceptually they're global. So, like, it makes sense again that you can basically, they'd have a different sort of loading indicator than, asking if a specific resource is loading. Say transitions haven't been solved. You're talking about the browser, right? I mean, I'm talking about in the scope of what I'm talking about, UI frameworks in terms of, like, and I'm not saying solved. I'm saying, like, because we've been working on solutions on it. I'm just mean, like, what we're calling transitions here, which are kind of transactional. They're not quite transactional though, because there's difference between transactions a little bit, at least the way the stuff is working right now, which is actually, we're actually almost at that point in the conversation here, right? When I'm looking at this in React, because if you have a single future, you can kind of cancel transitions, but once you layer them on top of each other, they become entangled. That's the term that we use, right? Because if you're doing a transition and then you add another transition, and there's only one future, conceptually, or one transition, then they all become the same transition, and it finishes when the last one finishes, so to speak. So, like, essentially, oh yeah, okay, well, locally, like, say if you update root state instead of local transition project, yes. What I'm saying is, it has, and this is more obvious from, like, because React has components, so when you update the state, it belongs to the component, so you can say that it's localized to that. I just mean that the mechanism is derived from not where you do the writing, but from where the source of the write is from. So it could be root state, it could be global state, it could literally be, like, it's not as tidy, because, like, it could, the classic problem, right? If you want to put something impact multiple places of the UI or be accessible by multiple places of the UI, you have to hoist it up, right? Or hoist it out, right? So, like, what I'm trying to say here is, like, suspense is very clearly, for example, a boundary where you're like, look, if I can't render my stuff locally, bail out or show fallback or whatever. Like, there's no question there what the scope is. It doesn't care if you load this data over here, under here, over there. It's going to be like, okay, can I render? Yes, no. Transitions are kind of like, they exist in space, like, outside of the, like, you could write anything. That's what I mean by they're global. Like, their application isn't necessarily global in the end, but their potential scope is anywhere. It's not like you're not just like, it's not like a UI zone region concept, unless you force it to be. As I said, there are ways you can, like, say, I'm going to fork only within this context, like in a router or something. But your router in that case probably has to be higher level, because it's the one responsible for doing all the transforms and handling all the forking for you. So then, and routers usually are top level, but I'm just trying to say, like, this isn't, UI can change, UI can shift, the where you need to show something can change, right? And something like suspense is very clearly like, these elements, this matters here. Transitions, it matters where the state is defined. Okay, so where was I? What was I? Sorry, I lost my train of thought here for a second. Was I looking at Twitter? No, not quite yet. Yeah, it's talking about the different loading affordances and how that's a consideration. Okay. Yeah, sorry, no stream this Friday. We Friday came early this week. Still, this is a fairly straightforward approach for React, because this loop that they get in from 2 to 4, while it has some new use considerations and stuff, once you get to 5, you're back to business as usual. So when designing concurrency in a signal system, it was a little bit trickier, and I don't necessarily want to get too much into. I'll talk about what I did in 1.0 a little bit. It'll come up, but I don't want to focus on. I want to focus on like what the solution should be. Now that we can have like a high level understanding of like kind of what React does, and like about when I'm talking about transitions being kind of a global thing, what I mean by that. Okay. I'm going to write out the algorithm, at least to plan for it, to make sure it sound enough. Pretty much my thought off the top of my head, so my perspective might adjust as I go on. And it probably has, because I've actually implemented stuff now. Start transition sets transition to be created on the next micro task. Create a global reference, including the transition queue, and run provided function. For those of you who aren't familiar, we'll talk about actions in a minute, but transition API generally involves passing a function that scopes some kind of write. Now, this is actually an optimistic state write, so that's not a good example. But I mean, I can show it in Solid's tutorials right now, right? We also have a start transition. This is Solid's API today. I'm a little bit proud of this one, because even though React had used transition, their original version had start first and pending second. And I actually was like, that's weird. It should be read then write. So I swapped them, and then React ended up swapping them when they released it. But originally they actually had them in the opposite order. But what the API, from an API standpoint, the way that we've been doing transitions basically there's some kind of start transition function that you wrap some kind of state update around. That's the gist of it, basic. And that way you can write state outside that's not part of the transition, and you can write state inside that is part of the transition. And again, this is important. I did a whole stream like a year ago about like why we can't just, there's the affordances I've talked about, why we can't just like make this the default. But sometimes like you don't want all the things to change together, right? You have to understand like there is context here that we can't just infer, right? So as much as everyone in the world hates this API, this is why Svelte didn't do this. They were like, it's weird to have transition and deferred value and all this kind of stuff. You know, we just want like a base model that makes a lot of sense. And I agree with them. I have to go back to here and be like, well, how do you handle all the different situations, right? And the answer for Svelte to async model is generally, yeah, you tear if you don't use their async stuff. Okay, that's fine. They bail out initially, similar to suspense. And then after the fact, they do a sort of localized holding. So it's not quite the same as transitions, but they make it so that like none of the components or everything basically kind of locks up until like when you do a set state change, until the async kind of comes through. And they look up at the compiled reactive graph to a certain degree to make some decisions there in terms of what to hold or not to hold. But like when the graph overlaps, let's say you're rendering the same section of the page or something, it will definitely hold up everything in that zone. So it's not quite the same as transitions, because doing that example that I talk about where you like show the counter while you're transitioning can't be done within the same local scope in Svelte. They don't have a way of like, it's almost, they didn't kill the reactivity, but it almost feels like they killed the reactivity. Luckily, they give you an affordance by passing the pending into the block where you do the async. So you do get the ability to get the affordance locally this way, right? That's one of the challenges. But they basically have a kind of pseudo localized transition that's not quite as powerful, but probably maybe good enough. So as I said, you can always come back to this matrix when trying to like talk about async, right? Because this is really the only choices you have. It's a matter of coming up with reasonable defaults. And the first thing we all have to realize is if you do nothing in a framework, one is always the default. So if you've watched my previous streams in Solid, what I've actually done now is make one the default always when you're not using the async features, bail out initially, but then go back to one once the data is loaded. Because I had an interesting conversation, I guess, a couple of years ago with Dan Abramoff, and I was like, why aren't people using transitions everywhere? And he's like, actually, we think use deferred value is actually better for most like on-page mutation cases. And I was like, oh, that's really interesting. He's like, design systems, routers, yeah, transitions, but for most on-screen. And I was like, and yet use deferred value takes some thinking. Most people, when they're using these features, don't, and then just have suspense yank out on them over and over and over again. And then they have to learn this new concept. So I was like, if you've seen like the Solid demos that I did like a little while ago, we made tearing actually the default again, because that's what people are used to and what they expect. Which again, it's not consistent and it's bad, but yet it's the default when you add async to sync. So it seems like the most sane thing to actually do. Bail out when we can't render it. And then how do we solve transitions? Well, it's still a thing for, you know, the specific cases that need it, like routers and maybe design systems, but the average developer actually doesn't really need them for most things. So yeah, I still think it's important, but it's like, again, I'm using this as my kind of matrix to make these two kind of decisions. So let's get back into here. So where was I? Okay. Start transition sets transition next micro task, create global reference, including a transition queue, and run the provided function, which is that transition function I was trying to show here, like this function, transition function. Upon write, clone signals and all downstream dependencies. I said maybe during notification. I decided just to clone it first, then notify. Queue all these into a separate transition queue, which is separate from like the main reactivity queue, which substitutes. Collect promises if the transition function is async. We'll talk about that in a minute. Run the pure queue of the transition queue, which this is why we split effects. Basically, run the front half of effects, all the memos, all this, like all the what we call the pure stuff before the side effects. Basically, all the calculations. Any newly created nodes are not part of the transition and can be queued into child queues as necessary. That probably doesn't make any sense to you, but my point is you only need to clone the nodes that get notified. Any new nodes are just normal nodes and can just participate in the graph as normal. Collect the promises from any reads that are async. Like in Solid, we have create async calls. I'm actually not collecting the promises. This is what my original thinking. What I ended up doing is, if you watch I had a previous stream where I showed off a cool stack blitz example in Solid. Stack blitz. Sorry. I'm just gonna. I probably won't be signed into here either. It's been so long, but I won't have to sign into GitHub again. This one, hopefully. The dev example, yeah. Transition plus optimistic state doesn't mimic the tear approach. No, well, it's I was talking about this before, because transition plus optimistic state is like what I call kind of predict the future. In a sense, you're not holding completely in the past. It doesn't, because you have the future state presumably, or something that looks like it. It's kind of like this golden area, right? Because it doesn't tear because you have the future. So like I wouldn't consider that tearing, because user ID does equal user. You know what I mean? Like so it has the it's just, if number 4 is real, that is what number 4 is, right? Like it's basically this idea that you just have the things the way that they're going to be. You have immediate feedback. It gets more like bailing out, actually. It's more like this, but you have immediate feedback. It's consistent, but you can't always do it, right? I'd say tearing is more like where you, like, transitions always hold, except in the case of adding future stuff that could be there, which means that they can kind of close between holding and adding optimistic updates. You can close the gap between being in the past and being in the present without being inconsistent, and without being jarring. So yeah, I mean, this is the goal here ultimately. But yeah, I wouldn't consider this mimicking tearing, because it should, you should apply the optimistic updates consistently. You know, I guess there's a chance that you don't, but that's kind of within your control. Sorry, where was I? Yeah, this example. The dev example, right? Yeah. I use this example because, oh yeah, I'm gonna. Did I already change the? I already changed the UI, the API on this. Oh well, whatever. The reason I wanted to show this example for a moment here is because it can, like, without transitions, this is tearing, right? You can see it. I'm showing a pending state. Yeah, it's sent to automatically randomly error. But it's showing a pending state based on the loading state of these async resources. So when you see, when I click, once it actually loads properly, yeah, here we go. I click, it grays it out, but look, 3 updates immediately before. This will be 4 before this becomes 4. Look, 4, 4, right? So this is tearing. This is the default. There's no transitions. I'm just, going, hey, is this pending? This one resource, loading state. So this is how you do, I'd argue, this is how you do tearing right. Whereas if this was a transition, these two would be locked together. But for a lot of people, all they care to do is go like, okay, I got, an ID, I'm going to create async, I'm going to fetch something, and then I'm like, show me a loading indicator, and I'm done. And then I'll wrap the whole thing in suspense, just so that when I load the page, it can load stuff, right? There's a bit of a cascading waterfall for streaming, but then after the fact, I'm not falling back to suspense. As I said, if this was React in this example, we'd be yanking out to suspense every time we click the button, right? So this is what it looks like to have tearing by default. From both a UX with suspense with a UX thing. So I'm pretty happy with this, but I do recognize that while this is good for 95% of what developers do, things like routers, you want to handle more holistically, right? You want to have transitions. I understand that you don't need, like, this is pretty good. Like, one, stop erroring. It's like the random error thing. I got that from Ryan Florence from Remix. They always feed errors into the demos, which I think is absolutely genius, because you should show race conditions and error stuff. This demo is still useful, dev. Anyway, so, but my point is, inside our rendering, like, we have, like, these compile into effects essentially that have a front side and have a backside that does the actual DOM updates. So what we can do here when we're designing our transitions, the reason I showed this example is actually the error boundary. Sorry, now I remember. I realized that our suspense or error boundaries, like, and this works the same way with error boundaries as well. Error boundaries actually make a really good example for this. See how this is errored? The error boundary is down here, right? The data fetching is up here. How is it that when I press this retry button here, it's actually able to try and like trigger suspense and load the data again? Data fetching up here, error boundary down here, right? On click reset. What does reset do here? It's actually just something being passed in from the error boundary. So how the hell is it doing this? Well, it's because the way the error boundary works is it actually collects the errored out effects nodes, the pure parts essentially. And then when you click retry, it goes, okay, these are the errored effects that can't render. It just reruns those nodes and pulls all the data again, which triggers the async to fetch again if it's errored all the way up the tree. If it stopped somewhere else or there's somewhere else, it's not going to get up there. But it literally pulls down the specific reactive graph to be able to rerun it. And suspense actually kind of works similarly. We don't collect the promises, we collect the effects that are not ready, essentially, and go, okay, let me know when they are ready. You know what I mean? So like, as they complete, as they're able, like their async dependencies update, they schedule, they clear, and they go, yeah, I'm good. They remove themselves from the suspense boundary, and the suspense boundary goes, oh, I'm good, I can show myself, right? So like this error boundary has this kind of similar dynamic here, because either you click retry, which pulls, like I mentioned, or when you're navigating to the next page, remember this is solid. We're not actually recreating all these components here. They're actually like swapping under us, right? Like the here, there's no show. We're actually keeping these same elements as we're going to the next one. Obviously, like when we show the fallback, we lose this, right? But what I'm trying to show is when we click the next button here, it also ends up causing those effects to rerun, which also remove those nodes from the error boundary. So both the retry and the move forward next work without rerunning or re-rendering any components. And I thought this demo was crazy to show the power of this. But this same node collection technique applies to transitions as well. If you tear an async file, when you're stuck in an error UI, yeah, you could see. I'm not actually sure how much rollbacking is actually happening. That's why I see a big difference between transitions and transactions. I mean, let me explain a bit. When you have a single feature, like I'm talking about here, like React has and Solid 1.0 has and whatnot, as soon as things become entangled, you can't really roll them back. You have to roll back the whole thing. But what if the first thing passed and the second thing failed? Now you can't do it. I think the whole hope of rollbacking transitions is a pipe dream. Honestly, I think this is more of like a good way to handle scheduling of async tasks and less of a transactional model. I think that's why I was working on solid transitions and I called them transactions, and I'm like, no, these are not transactions. I think it's important to understand that. I mean, React talks about them like they're transactions. And maybe React's approach to multiple that they're working for is kind of working on transactions, but it's very, very difficult to unentangle something. And if you don't entangle it in the first place, you have to almost enforce order, which means that are we going to be sequential? Now, if you're a database or something and you're close to where the right point is, and you can do that, you can go, look, I'm locking this, classic transactional model. But when you put a network in between you and this operation, yes, in theory, but I'm saying I don't think you can even do that. I think you just have to go with it. we already have things like error boundaries and suspense to handle the odd cases out and whatnot. I think it's an odd scenario to be in, to say that like for sure that like you didn't want any of this to happen. Like what if you like updated the database and then did this? Like if something errors, you are in a screwed up state regardless. And I think the UI probably should reflect that. So like, yeah, we're gonna get there. The implications of it in a second. Collect promises, transition async, blah blah blah. Reasoning. If promises are not all resolved by this point, do not run the effectful side of effects. When promises resolve, restore transition at each point and start from 3 again. So this is the loop. On the React example, I had it 2 to 4. Here's 9 to 3, but it's the same loop. Eventually, all the async resolves, and we are at the end of the pure queue. Merge back the clone nodes and run effects. So it's kind of the same thing, right? Like you can see that there's differences here. In React, their rendering, like their whole render tree, is the pure queue, and in Solid, I did a great diagram a while ago. I don't think I have it in Excalibur anymore. I mean, I can try zooming way the hell out and see if I actually have it on here, but I don't think I do. No, it was on my old computer, where essentially I was comparing the timing of split effects with the timing of like React life cycles. You can view the signal graph up to the front side of effects as basically the same as the React render tree. And then the back side of the effects, basically the equivalent to the diff and patch. So by doing scheduling this way, you can basically do a granular, non-component based version of basically the same thing, right? You follow the data instead of the UI tree, but it's essentially the same thing. Well, the benefit of this decoupling is you don't have to re-render components to do stuff. Yeah. Get not post. And to be fair, post is a big pain that we're going to talk about in a second. Because the beautiful thing about get is we haven't showed this in our simple playground example so far, but you can see it here with like create async and stuff. Is we can see the trail. Like if get phrase here is based on count, we know at the point that you call set count here, like this is where you'd wrap the transition in this example, right? When you click the button, you update the count, you go transition set count here. When you set this count on the get side, we know that this depends on count. So this depends on count. So where else is phrase? Or this depends on count. This depends on count. This depends on count. This depends on count, which means this depends on count, which means this depends on count. We actually built out our whole dependency graph, and we know it right from the point of doing that, either from setting it here or from setting it in a transition. We can actually see the whole dependency graph of everything that would be impacted, right? And this, again, this is a superpower of signals. So where are we here? Yeah, what did I say here? A lot of details. Start transition, set transition. Start transition sets transition to create the next path. We do this to finish the current execution, drain the current queue before starting. Even chain queues should run synchronously after you're running the queue, so except for additional transition fire at the right time. Okay. What I mean by this is I realized something while I was working on these things that it's kind of awkward. You want to drain the queue because if you're going to clone the nodes and they're already in a notified state, then you have to be responsible for running them on the transition branch. You actually want the queues to be completely drained at the time that you create a transition. To create a global reference, including transition queue and run provide function, we need both an active transition and for all current transitions. Okay, so I'm already suggesting at this. There's nothing about this solution here that doesn't allow for multiple transitions, right? There's nothing really about this that doesn't allow for multiple transitions at the same time. The challenge with multiple transitions is managing entanglement, right? How do you know if these things are like should rely on each other or related, right? You don't want to like finish out a transition and have, you know, something else working on the same data at the same time or trying to pull at the same time and then having them kind of like do a weird like you could end up with tearing again, right? So how do we like you know, like if you fetch something based on two signals and one updates in a transition and then another one updates in another transition, you know, like you don't want to be in that intermediate state. You're like, okay, fine, I'm gonna have to wait till the final fetch. Like in that case, you end up fetching twice because they're two distinct events that triggered those two transitions. But you should know that like it's the like you want the one at the end that has both state changes to be the one that reflected, because if you kept them separate, again, and we'll talk about this more when we get to actions, it's possible given async timing to get unexpected results, like the second thing to apply before the first thing, or you know what I mean? Like it's you show like in this example where there's the two different things, you actually like show it in one half state where it's tearing all over again, essentially, even though it's like done during async time. It just, you don't need those intermediate states in the UI. So yeah, yeah, I have some details here that probably not too important. Upon right, clone signals and all those streams event cloning. Let's talk about cloning. We want to clone them back to basically initial state. We don't clone cleanup or children. We need to backlink dependencies and observers, though, since it's possible for the main thread to cause an update that trigger these. So any new clone is going to clone observers, but it needs to add any clone of those observers as well. So yeah, this is kind of a fun little graph I was playing around with, kind of trying to understand how to do this. Because when I started cloning, I was like, okay, I'll just clone all the links between these things. But if you've ever seen a signal system, they dynamically manage their sources. So you can't give a parent, you know, multiple versions of the like different sources, because depending if the main branch or the transition branch reruns, you'll delete the other half. It's kind of a funny problem, right? Like if you try and clone everything, not everything gets cloned. I'm only cloning things that are direct dependencies. I'm not cloning like it's possible to have a source that's outside of the transition. Like here, that one's not going to get cloned, even though like this is the thing that you edit during the transition, this part of the graph. Then you have to clone on the downstream, but the downstream can rely on things that aren't part of the transition. And those things can still change while the transition is going on. So it's important to understand that like, it's a little bit tricky here, because every time this reruns, like maybe these arrows are the wrong way, because I'm basically showing like this is a source of this. So it's more like that way. It's the source, the observer array needs to include both versions, but the source array needs to only include the original and then backlink through the transition version. This took me a while to figure out, admittedly, but the end result turned out good. The other thing that I realized, and I mentioned here, is that we don't clone cleanups or children, because the child is running on the transition branch. You don't want to clean up the currently visible branch, right? So when you clone it, you can't, you treat it almost like it's new again. So it can run. And then when the final thing merges and goes, okay, I have the new version of this node and the old version of the node, at that point, you call the cleanup on the ones that are there on the main thread when you merge them back together. But the funny thing is, in the middle, those things could update, right? So they could run their own cleanup functions, you know what I mean? And inside the transition could also run its cleanup functions. It's not just the original state. These things are live nodes. But it's important that when you start the clone doesn't contain either the children or the cleanups, because you don't want to clean up the original. Merging on clone, right? Other condition here is if a write would cause a transition to become entangled. Yeah. So you start one transition, you start another transition. How do you decide if these are independent transitions or these are the same transitions? Now, I'm taking a single future approach still here. I think I realized as I kind of are walking through this, right? A single future doesn't mean you can't have independent transitions. It just means that if things overlap, then they have to be entangled. And the benefit of single future is there's no complicated merging problems. You don't have to worry about what do you call it? Like sequence. The individual resources have to worry about race conditions, like the async parts, but the whole graph doesn't have to worry about the sequence, because async, it's hard to decide what the sequence is, right? Because it's like, who wins? Like, because there's the thing that started first, and there's the thing that ends first, and those are not always the same thing. Do you apply them in the order of what started first? Like you have priority, you have a lock until you're finished. Well, then you're completely sequential, and that really sucks. Do you for a lot of things, it's hard to make that a default. Do you just, does last one win? Kind of, but yeah. What if something cancels in the middle? Like there's a lot of complexity there. So what I realized as I worked through this was I'm actually talking about single future, but there can be isolated parts of that single future that can update. Yeah, maybe we do it ends last. Yeah, right. That's probably the most sane thing to do. But as I said, it's interesting because that's the easiest way to kind of clobber or kind of like come in. And I think you have to. So the trick with single future is if the things overlap, you just assume that anything coming in will like become part of the same thing, and then it gets incorporated. Because if you have two different things going on and they overlap, they're not going to see each other, right? Like this includes like this sort of scenario. What if someone updates this in a different transition now, like this outside one? It's not going to, if you don't entangle them, it's not going to see this change. It's not going to know that this one's changed. It thinks it's its initial state. So it's working off here one tree and it's working off another tree. Now, maybe in React, they don't mind like having all these predictive futures and then like merging them at the end when this one finishes and then this one, and then figuring that out and like apply. Like, I don't see how that doesn't cause three different fetches, right? Like if this is an async thing here that fetches, so initial state, good. Transition on this comes in. This value, new value B, old value A, fetch 1. Comes in, transition, doesn't see the other transition. New value A, old value B, fetch 2. 3. One of the transitions finishes and he goes, okay, like whenever it goes to merge, it's going to eventually have to do new value A and new value B. Yeah, I mean, if you want to control how the merging happens, there's also other ways of doing this too, right? Like I'm not too worried about like the API aspect of it. Like you're saying, like give people the control whether to name it as the same transition or not the same transition or whatnot. But like I'm just like they have to be cognizant of the shape of their graph, and then you're like, okay, well, just let them kind of go with it, I guess. Right, like you could do that, and give them all this control, but like I think you have to really question whether you want like this is already a very complicated and advanced API to use. I think it is potentially very error prone. Whereas just kind of going like, okay, we know what overlaps is a very straightforward way of just saying like, because like the worst case scenario is the way that transitions work in frameworks today. The best case scenario is that the things that are isolated don't are able to run out early. And like I don't actually think the current state of single feature is actually that terrible. for most things. We'll get to where the issue is in a moment, but it is worth pointing out that if you entangle them, or when you hit the state, then it does fetch a second time, because basically this transition becomes based on the top of this transition, right? Because like if you kept them separate, right, then they could, and this one canceled, then you're also in a weird three fetch state, where this one will fetch twice. You'll originally have old A, new B, and then when this updates, it'll have new A, new B, because you've entangled them. And I think that's fine. The thing is, you won't get a result until you get the new A, new B result. You're not going to get the result on the first part of the graph, but that's, I think, fine. Transitions are complicated when Replance is having trouble with them, and he's the guy who's affected. Yeah, I mean, this is a tricky topic. If I think there is a potential future where React does go to looking at them like transactions. As someone who only cares about the UX aspect of it mostly, I don't know. Let's see. I can't make conclusions until we get to the end of this. The other consideration here is if cause transition to become entangled from the same transitions to distinct ones. If you were to write any of the same sources, it definitely would, but would isolate signals have to read the same computations? And I think I just answered that. Yes. I do talk about this. The approach we're talking about has no explicit cancellation, only merging. You can only move forward, not backwards. This is the way the React system typically operates and should continue to. In the case of these pseudo cancellations, the transition might linger longer than it needs to, but it will essentially die on the final merge. Yeah. Queue all of these to transition queue. Yeah. Collect promises transition is an async function, right? This way we can kept promises actions as reads. If we want subsequent state to happen inside transition, we wait, we need something. Yeah, I started talking about this API. It's not my favorite, but we can't re-inject our context after an await without passing the function through. And this makes the same transition. Again, using names or some other mechanism could accomplish this. But the idea here is you can go set some kind of optimistic state or something, await saving the database, resume, set some different optimistic state maybe, and then await something else, do a sequence of things. We don't have to worry about change awaits because the transition will wait to get the whole promise back. Yeah. There's some thought whether the resume function should have its own resume, etc. But I think we can make it if you call resume with an already complete transition, it errors. Okay, fine. Run pure queue of the transition queue, and any newly created nodes that are not part of the transition can be queued as queues. I haven't figured this part out. This is when we get to suspense. We'll probably talk about this. So I'm not too worried about this yet. Collect promises. I already mentioned how I'm going to use nodes to collect the nodes, not ready nodes. So I guess it isn't promises as much as not ready effective nodes. If promises are not all resolved by this point, do not run the side effects. That's a simple check. When promises resolve, restore transition at each start point. This is interesting since only collecting initial promises from transition resume. So we need to be able to handle the checks as well as be able to drain anything to schedule the transition. So it's a bit two pronged. Yeah, basically what I did is I have create async when the promise comes back. If it was created, if the create async function, like here, like if this function here runs during a transition, when the promise comes back, I just call resume on that transition. And that basically allows it to go. It basically does a second round of cloning from that point if it needs to. But they should already be cloned from the initial notification. But yeah, it just basically lets the rest of the graph continue on. It could be controlled over generators. I looked at that API, right? Because the only problem with generators is TypeScript, right? Let's go back here for a second. Because if you yield a promise and you actually need the return results for it, TypeScript is a pain in the ass for this. But yeah, people would have to get used to yielding promises or values. But yeah, people have to get used to yielding promises. This is what MobX does in the flow component. I did definitely look at the MobX flow component for inspiration, but it was like the thing that people are secretly hoping for is that when we get async local storage in the browser or async constants in the browser, we won't need the resume function anymore. We'll just be able to assume that we can inject the state again after the await. The yield syntax, I don't remember where I was concluding on that, because I definitely, you know what, let's open HackMD. I think I actually had a whole HackMD just about this specific API shape. Where is it? Yeah, I have a whole hack on MD on how to. Okay. Yeah, let's talk about that right after this one. But yeah, it is possible. I identified, I think, 3 different APIs. I finally decided that this was the lesser evil of them. Again, TypeScript is just miserable when you're trying to design systems. Run pure queue as transition queue. Any newly created nodes are not part of the transition. That's fine. Where did I get to? When all prompts are resolved, merge back and run effects. It's the least more straightforward. We get to the point existing nodes can be merged. Takeaways. Okay. We only need to clone nodes that are notified during the transition, since we discourage writes and computations, which I've actually added a warning to in Solid 2.0 right now. This should mainly be in transition or resume functions, firewalls, or in firewalls when draining the pure queue. Everything else can be created as normal. When cloning, we don't need to clone children or cleanups. These will be created when it runs and don't want to clean up the original. Since this is a variation on a single feature, even if it can be discrete parts, we only need one transition-specific node cloned for an existing node. We have to be conscious of keeping independent graphs while still being able to notify from the main branch to the transition branch. This might take a little bit of fiddling with how we do the linking and lookup. So yeah, I actually solved all that, and I'll show them the code in a few minutes. But this is the core idea of how you can do transitions in a signals-based library. It was funny when I first did concurrent in Solid 1.0. I remember people, like very influential people in the React community, basically saying it wasn't possible to do with signals, and I'm like, no, I've already did it. I did it like a year ago, and they're like, no, blah blah blah. It's not. Like literally just kept on repeating the same thing. Like Paul Henschel from 3JS. Specifically, and it was like, no, I've remade your concurrent demo. It literally works. I showed it to you multiple times. People really had a heart disbelief that you could do this stuff without the VDOM. We already did in 1.0, but I think this is going to be better with this ability to isolate based on the reactive graph. We use the same technology, as I said, to figure out error boundaries and suspense. So why not use it here on transitions? Yeah, if you add an additional wrapper function, I don't know. MobX hasn't solved this to this day. There's a very, very long thread, and I just was like, if nobody in the MobX community have solved flow functions, I am not going to be the one that's figured it out. Right, like you can type generators, but can you type it so that it knows that anytime you yield a promise, you actually get the value? Like the reason is you do something. It's kind of weird what you do, because you basically, what you're saying is, I want, because you don't want to go yield a wait. I don't think that's a little bit too clunky. You want to go yield this, but you might be like, the code you might end up with might be like, drop it down here for a second. The code you end up with might be something like this: yield. Do this is right. It was getting this to be not promise of this value, but the actual value of it. Yeah, no arrows for generators is annoying as hell too. Oh, it's yield star. What's yield star? Okay. Yeah. Oh, it's yield star. My bad. Whatever. You get. But yeah, getting this to be, or is, if you do this, like you will get the proper type of, assuming that this is this. Anyways, that MobX has like literally a 3-year-old, like 4-year ongoing thread without like hundreds of responses in it that no one's actually solved this problem adequately over the like last 5 years. I think there was a trick because MobX uses classes that they could build it into like the class types or something. But like from the pure function standpoint, it all involved like adding functions just for the sake of TypeScript, which hurts me deeply. As I said, I also am hurt deeply that TypeScript impacts the shape of API design. TypeScript is, as I said, very, very annoying for designing APIs. Yeah, exactly. Like you pass into a function to get the function to get the types. It's doable. It's just again, if someone says you need to wrap something in a function for it to work with TypeScript, then yeah, I'm like, seriously, because then now it's like, oh, is this a function that we also have to send out as a part of our library for type so that people can do this? It's just like, I know people are used to doing this in TypeScript, but you know, and maybe I should be like, take that stance that TypeScript users are crazy. It's just really dumb when you hit issues like that. Anyway, right. Let's talk about. So I introduced a moment ago that, you know, what if how do you deal with showing pending state for transitions, right? That's kind of like the next topic here. It's very relevant for optimistic updates, like for like actions, which React calls the actions like an async function passed to a transition. Solid, we had a special action wrapper, and I think the Svelte kit ended up using the same approach Solid did with the action wrapper. Remix has those like exported functions, or sorry, React Router 7 version, whatever, has the exported 7 functions. But like, generally speaking, conceptually, there's a mutation part of this transition async part of the story. Both of these problems actually are kind of similar, and React actually might have come up with a really elegant solution to it. I was talking to Ricky, and he convinced me. So let's talk a bit about this, because when I first went into transitions, what I kind of wanted to do was like basically await transition and go like set pending, await transition, set pending false, like as a way of handling it. And then I was like, ooh, the await's too late after the fact. So then I was like, what if I make it a callback? So like when transition function, and then when transition done, callback function, then we can call it synchronously, like before the transition ends, right? Because there's this time period between when you've done all the pure calculations and you haven't applied the effects yet. It'd be really nice to be able to like do a few more updates in there and then apply the effects. If you do an await, it's going to be after the render, so it's too late. Right. So here, set pending true, transition, set tab B thing. That's my thinking. Right. And I think I was also really interested in Vue transition API. I thought, I don't know if people are familiar with the Vue transition API from the browser, like start Vue transition. Again, a different type of transition. But the idea here is you can do animations, and then when you call start Vue transition, it basically starts doing a snapshot of the current UI. This is a lot like the freeze the UI non-updating thing. And then when it's done making the snapshot, it calls your update function where you can apply your changes. And then when your changes are done, it will transition the UI from A to B. Now, great API shape on the surface. You're like, oh, this is great. But kind of awkward. Because I was like, okay, wouldn't it be cool if we could just like make transitions work into this automatically, right? Because first of all, start view transition is not synchronous; it's async. So if like here's a problem, and this people will do in today. They'll start view transition here somewhere, like out here when they do the action, when they press the button, when they go to click save, and then they will await the transition stuff inside the callback function. So it'll snapshot, and then it'll start the transition, call the callback function, realize the asynchronicity of our transition, and then when it's finished, it will do the transfer, which works. But it means that between you first clicking the button and this finishing, and there's a bit of a delay because it won't call this start transition right away, like because it's async, but it freezes the browser. So the whole time it takes for you to fetch your data to get to the next page, like or on the update, it froze the browser, the thing we didn't want it to do. You don't want this function to really be async, or if it's async, it should be like immediate micro queue. You don't want this to be waiting, because once it's done its snapshot and it calls this, it expects to be like to animate. The time between the initial call finishing or basically the whole time it takes for this to finish, including the async time here, if your update callback freezes the browser. So you shouldn't be using view transitions that way. But it means that it's freaking awkward timing, because the ideal time to do this is to call start view transition right when you're done the pure queue, but before you run the effects, and then run the effects in here, except this is async. So you actually are in the middle of the framework's render process, and then they're like, oh yeah, we're going async now. And you're like, no, but I have to apply my stuff synchronously. So you be like, oh, maybe it's an I call you kind of situation where you give them the ability to call your effect renderer, whenever they finish their snapshot. It's weird. Now, there's ways around this. You can like maybe provide an API where you could pass in like a promise that you can basically pass into here. So like you do your render synchronously immediately, but when your render, yeah, I mean it's tricky timing wise, because this is async. You have to kind of await them taking the snapshot. Let me think here. Do you have to wait them taking the snapshot? No, they can take the snapshot immediately, but you have to make sure that you don't render your effects before they finish taking their snapshot. So yeah, you do have to kind of wait them taking the snapshot, right? So even if you could say like, look, you don't have to call my render function. I'll just call a promise, that I pass into you when I'm done rendering. This still can happen too late. So like, and Ricky pointed out too, when I talked to him, that sometimes for things like suspense, like fallbacks, you want to use view transition, which have nothing to do with transitions. So like this wasn't the right fit, but I definitely was looking into this, because in my head, I was like, oh, wouldn't it be cool if you could just call start view transition right here in the second function in between when the like pure part and all the async resolves. So you're not holding the page while the async resolves. And then right before you actually merge in the transition effects, do the view transition. It seems ideal. The problem again is because it's all async, it basically won't play nice with us. So we have to kind of come up with our own solutions there. But yeah, I realized that we can't just merge these things together. There's places you want to use view transitions that have nothing to do with transitions, like with suspense. And the fact that the start view transition is async is very painful for frameworks. They need the special case, which means you probably can't just hand this out to the end user to use the native APIs. You have to wrap it yourself, maybe in a view transition component. I know, a little tangent, but I just kind of want to put that out there, that like these are the kind of considerations that go into designing these API shapes and stuff. And I was really hoping for like, oh, look, we just use the native stuff the way we want it to. Unfortunately, the native stuff is designed in such a way that is very awkward for UI frameworks, as usual. But again, it's a very difficult place to be to kind of figure this stuff out ahead of time, because someone has to propose it and then be very involved with trying it to kind of figure this out. And it makes sense why this would be async, because taking a snapshot probably does take some amount of time, maybe not a huge amount of time, but it takes some amount of time. But can we guarantee, like, the snapshot happens before we render the DOM on the same synchronous task? I don't know. I maybe it does. Like, maybe the starting is enough, and the waiting is just when it finishes. Maybe this is worth like looking further into the spec. That being said, as I said, it doesn't apply for suspense, so I'm not going to worry too much about it. It doesn't belong as part of this API. You know, we could look at having a specific, like, maybe like on, you know how we have on mount in solid, like that it runs right at the while the effects are running on the like after the render effects. Maybe there's like an on before render kind of cycle, and if this does work in a reasonable way, then we could just hook in to that life cycle and then kind of use our same scheduling queuing mechanism, so that like you can call this function when it's off screen, and then when it goes to like merge in suspense or transition, that's when it actually runs, because it's scheduled to run at that point in the life cycle when it actually mounts, so to speak, or renders on screen for the first time. So yeah, I think there's like potential here, but it doesn't make sense to bake it right into transition API. Okay. So it's worth noting that React has something called use optimistic, which is like ephemeral state. It handles all pending states around transitions, converting into an equivalent solid with something like this: create optimistic, false, true. So the way the React version works is you just set some pending state, and then at the end of the transition, it gets reset to their initial value, right? So instead of having, you know, this before and after thing, you literally just go before, you know, and then when the transition's done, it's over. It automatically resets the base value when the transition ends. You can also make the base value derived into immutable overrides. So yeah, in React, they have this thing where you can actually base it on like a list and then like merge the stuff in. And this is actually kind of interesting, because I was thinking, I'm like, what if you made this a reactive list and then pass that list in and then apply the stuff in? But since it's reactive, but what if it's immutable though, right? Every time you get a new to-do, you're cloning everything, right? What if we just made that mutable, right? What if secretly under the hood, only when you add this function, like here's a signal, here's the signal version, it just swaps a value, right? Set pending, set false, right? This is like a signal, right? It's very clearly setting value. But when you add the second function here that does the diff, what if you just made it a projection? What if this is derived mutable reactivity, like we've been working on the last couple months? Then this gets interesting, because you can apply these once, do the fine-grained updates as you mutate it, and then when the transition ends, just diff back automatically. This is the Strello demo in a really, really clean API, because you could just like go, okay, if like this add to do doesn't have to be add to do. This could be like any number of actions. You can be like add to do, new item, do this. This is the mutations that come in, and then you write the merge function right here, and then you don't have to call reconcile yourself. It just basically all works and cleans up itself when the transition's done. So you just literally have like a switch statement of like on the different actions that happen. And the cool thing here is, instead of on every new one you clone and stuff, you just do the one fine-grained update, and it will only call it with each message once, and then apply each fine-grained update. And then if the optimistic update matches the final return value, then hopefully when it diffs back out, it will match and do no further work and not re-render any more components or whatnot. So this kind of gives you back fine-grained updates with optimistic. There's no cloning or, you know, kind of weird merging, and it makes use of the projection technology that we've been using under the hood. What if transition returned a promise for when it finishes and attaches? So you could do something like start view transition. Yeah, the problem is, and this is how people do install today, but you understand the problem here is this awaits for the whole thing. Like, what if there's async happening in the transition? The second you call start view transition, the outer view one from the document, it freezes the API, which means that the whole time you're doing async, it actually freezes the UI. Like, it's not interactive anymore. You want the time inside the callback to be as short as possible. So you basically want to do the transition, resolve all the async stuff, then call start view transition right before you actually do the rendering. But because this is async, the start view transition, there's like awkward timing where you don't want to render too soon. What if the transition fails at some point? Will it revert to the state? No. Yeah, I think I already kind of went through this. Yeah, I mean, if it fails, you mean the optimistic state. If it finishes, failure or success, it will revert. It will revert the optimistic state regardless. Optimistic state is just, it's like pending here. It's like it was pending, now it's no longer pending. So yes, optimistic state only lasts the life cycle, the transition, success or failure. Basically, what I'm arguing is transitions can't fail. The operations inside them can fail. The way you render everything can fail, but transitions themselves don't fail. They just they don't error. They basically happen, and they complete successfully or errored, but they don't fail. They're just a scheduling mechanism going from point A to B. If you remove the transition, it's the same thing. A to B. You can't. They're not transactions, right? But yes, it will revert the state on transition end, because this is using projection, which means that it is what do you call it? It's derived, so it doesn't. If you can see my recent streams, it doesn't actually mutate the source data. It actually creates kind of reactive wrapper around the source data in a super fine-grained way. So yeah, not my last stream, but the stream before, I actually showcased how we could do derived fine-grained reactivity, and this is like a perfect use case for that, because it basically doesn't impact the it doesn't impact the underlying list, so you can always just get back to it. I see two benefits of this API. It separates the two halves in a way that makes the logic seem simpler. It hides the implicit diffing. Secondly, it turns object updates back into events. It doesn't assume you want the form data, you decide. It also doesn't care the shape. You can merge it with the actual list or keep it a list of optimistic things. You can have one handler for multiple messages or one type of handler. The biggest question, as always, is there a more basic primitive here to just handle optimism without the projections? In reality, solid, you'd almost never want the immutable form for anything with any depth. Basically, if you far enough to have a diff function, you want projections. So maybe that's the stance. No incremental function without it using a projection. But that's not true. I actually figured out a solution to this. We could have the setter function pass in the previous state. So if you want to do immutable diffs, it's like solid signals. You could have I think actually I have this in a different hackmd. Sorry. I should actually publish this one. Sorry, share the one I'm on right now. Publish. Sorry. I should have copied this into the notes already. But the other hackmd that I'm working on right here, yeah, I realized that we could also have the setter in the simple non-diff function version, like basically on the signal version. We could pass the previous value in, so you could merge it yourself, which is slightly different than passing the diff function version in, which uses the projection in the middle, right? You guys can see the difference here. This one, you just like pass in the item. That would be the new item. You do the merge in the projection, which is a mutable, and then setter function with the previous value this is it's like a single signal setter function essentially. So then you could do here with the simple version. The difference is this merges it with some actual derived state, you know, and then like you would use this if you were just collecting the messages. Like in Remix, the to do demo, and this is the same as Solid Start, we don't our use what's it called? Use action or use submission. Sorry, use submission pulls out optimistic data almost in this form, where it basically pulls out the list of messages, like the things that you save, like each entry you submitted on the form. It doesn't merge them, and then you use this ephemeral state to merge them in the UI. Essentially, like you go, okay, well, if I have a to-do list and I want to have I have an add to-do action, you basically, as it's going, you add the to-dos on this the state, and then you have a second for underneath looping or map function looping over the new to-dos. So the original to-dos are untouched and the new to-dos are added in the end, and this only contains the new to-dos, and then when it finishes, it clears it, right? Whereas this version, you would actually pass the original to-do list in here and do the merge in here, you know, fine-grained style. This is better if you want to like in the Strel demo where you're like moving stuff between board columns and want to do all this stuff. But then everything basically feeds through, like I call this optimistic only, but like you could, if you did it derived, like in this version, this isn't optimistic only. This is list with optimistic if thing. And then from here down, you use this version of the list instead of this version throughout your UI. Like that, this version actually merges the changes like as part of the primitive, and then you render the merged the previously merged changes, right? As I said, this is great for the simple case. It's the way actions work in Solid Router. This is much more powerful and making like advanced optimistic UI updates, I'm not going to say trivial, but much easier to get right. Second, are these localized? Our current API has nice trade-off of being declared globally. I guess our action could still work this way. Yeah, I was basically showing this, but actually I think the action API would probably work like this. But yeah, I'm showing that we could keep Solid's current action API in the router built on top of this. What's cool about this though is if you look at it, you know how today our transitions return pending? You know, this mechanism works for both optimistic updates and normal transition like pending states. And I think that's pretty powerful because you control what's pending. The thing that's always bugged me about like is pending or returning stuff like that is like now if you want to do something special with it, you end up having to derive from it, where a lot of cases maybe you just have two states and you can just feed them in here yourself, you know, like these optimistic states. You don't have to like try and derive them from a signal to give you. You're the one who gets to choose the signals. I think this is a much more sensible API. I was already getting away from our current transitions, like returning the pending state. That's why I was like looking at stuff like this, where it's just a signal. But I think this is actually even better. Managing errors. This all works nicely for happy cases. How do we see errors? Things on the read side naturally error when they're used. Things on the write side have no such ownership. I don't know if it's responsible for optimistic updates to contend with that, but historically they have for us. I think the answer most of the time is you don't want to upend the rendering. So the key to this actually is how you manage to return value from the action itself. So the idea here, yeah, is when stuff errors, actually this should have probably a resume in it, but when stuff errors, handle it in the action. Not don't expect the, again, if we make a specific solution for the router, like we keep our current action APIs because they're convenient, we'll wrap that logic for you. But generally speaking, using these like generic low-level tools, is errors are not tied to optimistic updates or pending state. You manage them, right? Now, obviously, this doesn't work great with progressive enhancement. So like to make it work, there will be wrappers around it, like the use submission from the router and stuff that like have the like these seamless things. Like I picture our APIs in the router here actually staying basically the same, but it's cool to have them built on a more baseline primitive that works in the more general case and is much more powerful. Patterns for async data. What do I got here? Yeah, I was started kind of wondering. Yeah, as I started working through this, I realized that because I've showed this before, but solid 2.0, when you pass a function to signals, they become derived signals. Basically, they become memos that are writable. And similarly, if you have a store and you pass a function to it, they become derived store, which makes them a projection that is writable. And I started noticing as I was playing around with these that without transitions, like just on the base case, you might do this a lot. You might fetch some async data and then turn into a store, basically, by diffing it. This is what the reconcile function does. And then whenever the async data updates from the server, you diff it, and otherwise you can just mutate it like a normal store. I can see tons of people using this pattern for doing like fine-grained store updates on async data, right? And in the sense, if you put these together, this is create async store, right? It's not too hard to see how these compose. The diffs the data wherever it comes to the server, but then you're free to override it as much as you want. It's basically the granular equivalent to a derived signal. This technically has optimism built in because you're setting the store and then you fetch manually. But when and how you say the data is up to you. It is very client-centric thinking. Conversely, with transitions, you might do this. You might go create async, fetch data, right? And then create optimistic, store, mutate, and then use those things to like I've shown before. You've seen this before. It's a reducer, right? The difference here is the lifetime of the ephemeral state is set by the transition that uses the mutate function. Basically, you can't update the store without also scheduling a transition that refreshes the data. It's a much more constrained pattern, but it automates a lot of the pieces. Both approaches use projections under the hood, but the latter is more guided approach, right? This is kind of like the you can do anything with solid approach, and this is like the happy path, like use the features properly approach. Okay. Should all projections look like this? I was tempted, and I went through this kind of side where I was like, what if projection API always looked like this, where you had like a baseline that you could derive from, and then you could like do this, because it kind of makes sense, you know? But what I realized is for this API to work, you have to be able to do the diff at the end and know how that diff works, which means that if you want to be performant and actually diff against the projected data and not like lose things in the intermediate steps, you have to wait till everything related to this projection is like all the futuristic stuff, like all the optimistic stuff is basically resolved, so that you can get rid of it and rebase it when the base happens, which actually turns out difficult to do manually. Transitions manage this for us, or can manage this for us, because transitions have a set guaranteed finish time, and you can go, look, until these things are entangled, until the transition's done, we can't, you know, clean this up. So you could be running multiple transitions kind of and getting entangled in multiple actions as you go, and be living in optimistic state for a while until you finally stop typing, and then optimism, you know, clears out and you're done. But basically, as long as the final diff happens when all this, you're sure that the server has all the stuff, then you're fine. But in the general case projections, you wouldn't know that, which makes this not a suitable API for projections in general. That's the short version of this long write-up. Yeah, the fact that it makes the win here is the Strello demo literally turns into this, which is just beautiful, because as I said, it's finally as easy, if not easier to write than like the React version of the code, and it's way more performant. So because it does fine grain all throughout. So I'm pretty stoked on that. But I haven't implemented this yet. This is the design thinking here. Yeah, use action state driving people crazy. We're going to get to in a second here, because I'm talking about the API design. I think actions are where we go to next. Let's talk about actions. I've done this one. What do I have left here? Let me just look at topics. Single feature we already talked about. Okay, actually, this is related. Yeah, what's my last hack MD? I just want to see if it's relevant to anything. Is create optimistic the right API? Okay. I might not get to this one today. We'll see. This is you have to understand stuff on the other side before we get to this one. So let's continue with let's actually go. Yeah, now's a good time to go address all the Twitter stuff related. Yeah, because I'm trying to remember where the best conversation for this happened. I think it actually happened on Blue Sky. It's hard when you have everything in multiple places. Oh, I forgot to say I was live. Oh well. Okay, cool. So let's look at this video and see what's happening. Okay, start at the beginning. We have 5 buttons on the screen, okay? Right? And clicking each one at a time, okay? And you see these fetching sequentially. I'm actually not sure if it's not just his clicking that's causing them to go sequential here. But the more important part is these 2 are finished already, but these still say acting on them. In fact, these 3 are finished and still saying acting. Let's keep going a little further. All of them are finished except for the last one, still saying acting here. And then finally, done. The answer is because there's a single future in transitions. These are all kind of seen as they all get entangled, right? So there's a comment here on this post that says, is there no way to use server functions in React without their pending states all being tied together? Which is fair. And the answer is no, basically, if you want to use transitions. You can use server functions without transitions, but if you're using transitions, then the answer is no. So yeah, this gets where the confusion starts. Ricky goes, yes, they're parallel by default in React. You may be using use action state in which you're opting as serial processing or doing the pending state and async transition, and all transitions are entangled together. Until we build parallel transitions. Okay, so one of the things is use action state, like their form processing version, actually forces them in order. But this one you can see it's not in order because it fetches, it's fetching 3, 4 at the same time. If this was use action state, it would do the first one, finish, do the second one, finish, do the third one, finish, do the fourth one, finish, do the sixth one, which is not great. There was a whole controversy about this because that's like the default behavior and no one was expecting that from Next. I, however, in my retweet here actually defended the React and Next position on this stuff, and I want to explain a little bit why. Not the use action state thing. I don't think almost anyone wants serial behavior like that. But this isn't serial behavior. This is just all the pending states being entangled. In fact, which means that it won't update the UI until the last thing comes back. And there's a very, very good reason for that, right? And I think we're going to have to do some Excalibur to talk about this in a second. Yeah, that's all I want to know. Use action state, you opt in serial processing, where else transitions globally tied together. I disagree with your take on APIs. Of course, this is artificial, though. How should I test the worst case? You're probably right. I do want to use optimistic updates here. In general, I probably won't suggest using action. Use action state how they behave. Also want to have rules without escape hatches. Plenty of websites have good Wi-Fi, clicking around, and having plenty of states all tied together. Single would not be a pleasant experience. Actually good and convinced. I'm sorry, I don't use extra forces this. Blah 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 blah. I think features that use actions for this barrier. It's opt-in when you option not use action, you raw actions to start transition, which run in parallel. Then you need to handle race conditions and out of order states yourself. saying that use action is required to use action, but it's not. You can change your thing. But the thing is, these are in parallel, and you're still getting this behavior, which is why I want to flag this out. Okay. So let's talk about this. Why do I think? Because I sit here, I need to remember to talk about this in the next stream. What React is doing is quite logically clear. I see a lot of parallels between actions and use effect. They break the dependency graph so you can no longer automatically be smart about what they impact. Even with better async primitives like we have installed, our graph is on the get side. It's derived. We can trace the state change to it appear in the UI. Set user ID, get user with ID, do this. I showed this a moment ago when I was showing Dev's demo, how we could like basically trace through this stuff to do suspense, error boundaries, even transitions. But actions don't tell us their downstream dependencies. Like use effect don't tell you what state to write to. This is basically the async version of the same shape of problem. Anyways, food for thought. What I'm trying to say is, and to be fair, the live view guy was nailing Remix about their optimistic updates, saying that it wasn't safe. And it's a very similar conversation here for why we have to use transitions this way. Because a lot of people see this kind of behavior and like, oh, this sucks, I'm not going to use it. And then they actually introduce a bunch of race conditions and they try and solve them, but then they miss a few cases, generally speaking. The problem is that it takes specific knowledge to know that you can't merge these together. Because as I said, it's not too hard for us conceptually to use the reactive graph to know when we can merge different transitions on the get side. But on the action side, we don't know what the server is going to be like. Oh yeah, invalidate this data now that you've done this action. We don't know that. And the problem is this. Okay, let's draw this out. Let's look at some kind of. I'm trying to think of how to best show this timeline. So let's use solid lines and let's do some kind of fill in background color. So start with red maybe. Let's fill. Okay. Because I'm trying to think of like how to show this in terms of timing, because there's basically the first step is let's do medium. Initiate action on the client, okay? Like, let's do this. Right. And then of course. And then the next state here is apply mutation on server. Let's give it a blue. Okay. And then I mean, it's actually, I haven't drawn this one before, so I have to actually think about this a bit, about where we want to yeah, I think I'm going to need more steps than this. I wanted to do it like this instead of a timeline though, because let's see if I can get it here. Initiate fetch on client. And then finally get data from DB server. And then, sorry, I just got one more stage, which is update UI and client. I mean, it's a little bit simplified. I'm probably going to need more steps here, I think. Do I have enough of these? Colors? Probably not. That's fine. I'll use these. You can this has mostly to do with optimistic updates. So if Next doesn't have optimistic updates, or Next, sorry, then you might not see this, but this can always happen actually. I think this has, I mean, a lot of solutions don't solve a lot of these edge cases for you anyways, which is why sometimes like when Jose was going off on like the LiveView guy on this stuff, I was kind of like, yeah, and so has every client-side application for all of eternity. So like, you just have to manage this stuff, you know. But I want to show that there's this sequence, right? And the challenge is these things can happen. I'm going to shrink it down a little bit. These things can happen with different timing, right? Now, it's not until we get to here that we know with an action like what the downstream impact is. This is when we like this part up here, like get is here. And I'm not going to include single flight mutations for a second here, but it's the same kind of conceptually thing. Like I'm only keeping this for a second, but I just want to point out that there's two parts of the cycle. There's the post and then there's the get. Right? There's the mutation and then there's the like, you know, revalidation or whatever. Like it's true that this could just return the data with it immediately and then, you know, but the problem is like the impact of this could be more than just the scope of what launched it in the first place. This is why we have stuff like TanStack query, why, you know, we have loaders at Remix working at a fairly global scale at the route level. Like there is this part of the cycle, you know, React server functions that they include their server actions, I guess are now server functions to basically do this and then return server components, which is kind of like the get. Like there's this full cycle, right? You post to a page and get the next HTML, right? This is common. The thing is, if you have multiple of these things going at the same time, okay, right? So let's grab another one of these. And let's just offset them a little bit, right? This is the simplest case, right? In the simplest case, as I mentioned, it's only on the get that you understand that they are actually entangled. So if we just don't do anything special and assume that transitions are not entangled until they hit a reactive graph node change, the simple case is actually fairly helpful here, because the simple case, when you're doing the fetch on the client, you set the state. This is when the transition classic starts. And this Cell-Solid 1.0 actually works with its stuff. I didn't actually wrap the action part in the transition. There's a reason I want to in 2.0, but initially I just did it here. So what would happen is when this gets to here, it realizes that it's the same transition. It's impacting the same data set, right? If these would be entangled, right? We only care about the entangled case. In the not entangled case, then yeah, these things can go independently. We don't really care, right? But it's when we get to like set we go, yes, we succeeded, refresh the data with this ID. At this point, we have our more synchronous, like we have the full reactive graph in this get side. And when this hits it, it can see that it overlaps with this because it's happening at the same time. And what's beautiful about this is it knows this one happened after, right? So it actually will cancel out this one, so to speak, right? Because of like create async essentially knows that like it handles these kind of race conditions, which is great because, if something weird happens here, like you're doing this one and it suddenly, for some reason does this. Sorry. If this happens, you know what I mean? It's gonna go. It's basically gonna ignore this, and it's just gonna continue on from here. Like this part just won't exist. It'll just be like bye bye, right? But so you get some protection automatically simply by the fact that because these get locked in a transition sequence that and the because of the it actually technically because of transition will wait for them both to come back, I guess, which is arguably but actually if they're the exact same data being fetched, it will be canceled if it's the exact same like data source being updated because of the internals of create async. It'll just like basically cancel the first one, right? Okay, but basically this already is kind of helpful. The challenge is what happens if so most of the fetch side stuff gets handled automatically now because of transitions and async primitives. But what happens if these two miss each other? Like if I move this just a slight bit further to here. Now, oh, actually, this isn't quite right. I can move it a little bit further. We gotta move this to here so after this gets back, right? Because this can happen in solid today. The transition ends before this green part happens. So when this goes to go, it doesn't actually see that it overlapped if we didn't start the transition here. So, and it's possible, depending on when this apply server mutation on the server and this get data from the database happens, for this apply to happen before this get. Do you see what I'm saying? So this to actually get the change from this action ahead of time before it actually like should, right? And as I said, in a basic case, no one actually notices this in general. Okay, I can zoom in a little bit more, but I'm pretty wide here. Let me see if I can move myself down. Maybe this is better. What I'm trying to get at is it's possible for it to save on the server before the get cycle happens, and for this to update the UI with both changes, and then go to update again with both changes. I mean, this is not a big deal for normal UI, but this is actually a really awkward for optimistic updates because because the timing of this fetch happens after the transition ends, it doesn't make them the same transition. If you only start the transition on the get side and not on the action side, which means that like if this optimistic update was to add one item, and then this was to add another item, right? So you've now got 2 items sitting there. Well, like extra items on the end of the list. When this finishes, it goes, okay, I'm done my transition, and they didn't get interlocked. They didn't realize they were the same transition. So it removes the one item that it was intending to. The other item stays there, but it returns the data for both items. So briefly, between this rendering and this rendering, the second item is going to appear in the list twice. Once as new and once already there, right? Because it returned it because it already applied the mutation, right? Because these did not get interlocked. Like they didn't entangle because the transition started too late. Similar things with deletion, where like if one needs a deletion, you'll see stuff delete and then show up again and then delete again. These kind of things can happen with optimistic updates if essentially these aren't tied together as the same transition, but they don't know they're the same transition because the transition ends before this one actually figures out its data dependencies. This is kind of the challenge. The funny thing is, as I said, without optimistic updates, you wouldn't probably notice this because, I mean, we're all kind of accustomed to this kind of behavior. Like you're on a website and a different user updates the state, not you, but like a different user updates the state. And when you do a save, not just your new data, but like other data comes in too. It's a little bit jarring, but you're like, oh, someone else must be on this page, right? Yeah, I don't have time to make these kind of demos per se. But yes, I mean, these are just conceptual. Like, I think Jose from LiveView on Twitter, I maybe dig it out a while ago, did a decent job of like picking apart a website that had these sort of issues. You've probably seen them before and not realized the cause of them. But yes, this timing bit is a little bit awkward. The ways to fix it, right, is if you entangle this, then you know not to update you know not to do the update until the end here. Solved. But you don't know the entanglement. I also just realized the solid events creates a graph for the post side. It can tell us everything that will be updated right at the beginning of the event. That's interesting, right? Because one of the API choices is basically to tell the transition like this is what we'll update, but it might not know because the server might fail or work a certain way, and like you can dynamically choose what gets invalidated at mutation time, right? So like it's the other solution to this though that I was thinking about is if you're okay with this happening when optimistic updates aren't involved, we could just entangle. Like you have 2 options. You basically have to say, look, all actions, when there's actions involved, have to entangle, right? You can go like, you can do the get stuff as much as you want, but as soon as you have actions, they're going to entangle, which means you're basically back at this React example. It's not unreasonable. If they didn't do this, stuff like I'm showing you right now in the Excalibur can definitely happen, especially, and these are not the kinds of things like, as I said, people are accepting when optimistic updates aren't involved, but as soon as optimistic updates are involved, this is not the developer's fault for not handling these edge cases. This is the framework's fault. Like React knows that. If they didn't say this was the behavior, like, and you had your optimistic updates popping in and out, like they can't offer an optimistic primitive and not handle this case, right? So like it makes perfect sense for it to work the way that it does. I'm not action state, that's a whole other thing, but for transitions in general to work like this, that they encapsulate they don't know what's going to happen and they encapsulate the action state. But yeah, I mean, what I'm thinking is interesting is if these are related to the same data and they feed through the same optimistic updates, that could be the indicator that they entangle, right? Because without optimistic updates, you might not actually care if this happens. Do you know what I mean? So that's my working principle, at least right now. We'll see how this goes, but there's a whole bunch of situations you get when these timings compress or change or shift and happens before. Half of them are resolved by transitions simply from the synchronous data fetching point down, like just having transitions. The other half of them can be solved by actually encapsulating the whole process, right? Because now it's only if you start the action after you started the UI update that they're not potentially entangled. The beautiful thing about actions generally is you can, I mean, if you'll set the optimistic updates up front. Now, it's possible that you can be in the middle of an await chain setting optimistic updates, and then you won't know until the middle. So like the approach that React is taking right now is the only actually foolproof solution. It's just there's a certain question here that if we basically assumed reactive graph entanglement using stuff like optimistic updates, could we get there? Like one of the tools that I have in Solid that they don't have in React is I know the graph, right? Right. When React talks about parallel transitions, they're kind of talking about transactions, I think, and then figuring out how to merge them, and like it's kind of complicated. Whereas when I'm talking about parallel transitions, I can just like go, I know what's impacted from a graph standpoint. Like in React, the challenge is because the UI components pull lots of data together, co-location in the UI is actually what decides the thing. So then you can't really isolate any like thing within the same tree, you know. Whereas because again, transitions conceptually start from the global level. I guess it's where you set that state. So if stuff's in the same component, then you're kind of messed. Like there's nothing you can do. Whereas when the fine-grained approach, you don't actually care what component it's in, only if the graph overlaps. So I think this opens an opportunity for us to have different solutions in the space simply on the fact that we can actually know the dependencies of the graph. And this is what I'm talking about. Some of the applications of signals that go beyond what we can do in React today. But yeah, I mean, getting back to this thing. There's a comment on here. I thought there was a response. Maybe it was on the Twitter thread. Let's go to X. No, it's probably deep somewhere in the comments on the Blue Sky thread then, because it wasn't on my top level thing. 111, yeah. I think there is a comment. The React isn't forcing them in order. The requests are parallel. They just get grouped in the same transition pending state. So make like use action state. It's great. This doesn't do what I expect. Now my UX is very specific. Where I can don't use it. Do this stuff. Back to square one. Maybe it's a bit simplistic, but every time I touch new React 19 stuff, this are into it. It's like I like remix fetchers. I get them to problems you described are mostly backend problems. I want server functions to work with fetchers. Blah blah blah. Yeah. So he's using use transition, not use action state. I get it, global pen. The way not to get them is don't use transitions. Now I know, but it's tricky because if you don't use transitions or something like this, it's very difficult. Sorry, where's my Excalibur? It's very difficult to handle these problems completely because the number one thing you can do is control the sequence that these happen from the client, right? You can go like give each of these an individual ID. But you also have to know when to say cancel, which is fine. I mean, if they're the same fetch, or same action, but like you also, but if they're a different action but related to the same data, like there's so many permutations of how this can go wrong, that you basically end up building something very similar where you act like hold applying the state, kind of again forking it in order to get yourself there. Just so that I'm interested to see, but my gut feeling is in order to avoid doing what React does, when you have a solution to similar things, you're probably missing some edge cases in the general sense. Like maybe you have a specific solution where like, oh, in this case, do this or use this version of the API. But in a general sense, you can cause this kind of behavior. Probably. I can't like prove that, but my gut feeling is that there is some way to cause an issue if you're not entangling in these, just because there's so many different timing situations, and at the point where you're basically forking and creating your own updates, they again, this is kind of like when I'm talking about the physics of it all. They have to behave a certain way in order to ensure this behavior. I'm not looking at this as a React specific way. I'm looking at this in the general problem space sort of way, like we did with transitions or whatever, or async. The shape of the solution can only look a couple of ways and with certain caveats. Now, you might not like the caveats that the React team chose, but I think looking at this from a general sense, that has to be the solution unless you have some like clever trick up your sleeve, like maybe use the dependency graph or something like that. Whereas I think if you're already building in React, you're kind of stuck with the same tools that React has given to you, unless you specialize. But then if you specialize, you're not solving the general case. So I'm like, yeah, that's my gut feeling here. So yeah, this is why transitions are tricky. I think the most reasonable trade-off that I can think of right now is not caring about this if there's no optimistic state, because then you're used to that as a developer in the front end. It's only when you introduce optimistic state that you kind of feel responsible, that you're like, look, I can't have it be weird and janky. It needs to be predictable. When it's my own state and my own changes, I can't have stuff appearing twice or disappearing and reappearing. And in that case, maybe we can use the graph there. Anyway, I think that's it on this topic for now. But let me continue, because I want to show off a bit of what I've been working on. This is a tricky problem. I don't think people appreciate how it kind of has to operate like this. And I mean, this is my gut feeling on it. It's funny because I came to this independently. You know what I mean? This is not me like copying React and agreeing with them. I've been actually just working on this, not completely aware of all the React behavior. Like I only found out about use optimistic like a month ago. I mean, I knew about it, but I never looked into it. I didn't really think about it much because it wasn't the topic I was on. But so yeah. Anyway, okay. Let me get to the demo that I originally showed off that I wanted to talk about on the stream today, because people probably saw this demo, and let me close this up a bit. And they probably thought that I was basically showing the answer to this Twitter post. Like, look, it looks the same, right? They're independent. The key difference here is that there's no post here. This is purely get. So yeah, in case you haven't seen this, I'm going to share this link in the tab. This is a very early look at 2.0 transition approach, and let me kind of show the basic example. Basically, I'm using real DOM elements. There's no JSX compiler. This isn't like a solid build. This is just me literally in the playground hacking the solid signals implementation, and then just using DOM effects directly. But essentially, I made a component that has an ID that you can increment, has an optimistic pending state that gets sent to true and false, has async data based on that ID, which literally just appends a D to the front of the ID. Nothing creative here. Then I create a div and a button, and then set the text, and then on click, run a transition, which sends pending data to true and increments the ID. And then, some div stuff, just initial loading state, and then it has an effect. This effect listens to the ID, the return data, and some counter that's global counter that just keeps incrementing. And then I have a different render effect that listens to the pending state and like if the data is pending, and then sets the opacity based on whether it's pending or not, right? Which was the optimistic data from the transition. And then finally, I grab my app and then I append 2 copies of the component, one with name 1 and one with name 2, and we set up our global counter. Okay, that's a setup for this. Oh yeah, this I have not. I have not made this work generally, practically at all. Create effect is also different because create effect it doesn't participate in transitions. If you remember, this was the outcome of our discussion. I mean, we could try it on stream and see what it does and see if it's what I expect it to do, or if it just errors out and it doesn't work. But generally speaking, because for the same reason here, this effect is reading from phrase up here, and it's not suspending the whole phrase counter. We said that only render effects participate in these node collections because this doesn't have to do with rendering. So this gets held up on the graph when it's like it only runs when it can resolve async, but it does not like throw up to a suspense. This is how we can have an effect that reads an async data above a suspense, whereas the rendering happens under suspense. Otherwise, it would move all the way up. Okay. Similar idea when working on this example here. So render effects are key to this example working. Okay, so it's like just broken. Okay, fair enough. Yeah, so basically, when I increment this ID, you're going to see it turn gray, right? For 2 seconds. The counter's at every second, so it goes 8, 9, 10, flick, right? And if I jam this like 10 times, like you see that it actually waited until the end to actually show the updated data. And the key part is this count keeps on counting throughout. I told you to actually prove transitions, you actually have to have a counter going, because that means that there's a version that's locked up on here, and there's a version that continues to count up in the foreground, right? But the key part is ID 9, and like these are always the same. They're always consistent. The ID cannot get out of sync with the data, right? And that. Now, as it turns out, and obviously I did this very easily because I just made it all into a component that does it. In real app, it's more complicated. This transition is completely independent because it doesn't share any part of the same graph, right? It sets a different signal, has a different optimistic update, has a different async. So there's no reason for these to entangle together. So I can hit this 5 times, hit this 5 times, and they can run independently here because I can create multiple transitions at the same time as long as they don't entangle. If they do entangle, that's what this case, when I hit it multiple times, that's them entangling. That's why they wait to the last one. But these ones are completely independent. Yeah. So, I mean, that's the basic example. See, if you don't have a transition in this example, and we do this, what ends up happening is ID goes, and then that goes. ID goes, then that goes. Yeah, you can hit it like 6 times, 7, and then it'll jump up to 7. That's create resource or create async, sorry, managing managing the race conditions. And again, this is not blocking and it's parallel. This is what happens when you don't use transitions, right? But this is what tearing looks like. That's it. What's cool about this example is there's actually no suspense anywhere in this example. I can show this off because of the way we do tearing. But what I'm getting at is this is fine behavior for some stuff. But and you can always go back to this, but transitions can give you that guarantee. And as I said, you need to add the affordance, which is why there's this optimistic update, because without the optimistic, it doesn't, there's no like, I mean, you can visibly see it. I'll just cross out this effect for a second. Without the optimistic, there's no immediate feedback. You can't tell what's going on, which is why like transitions kind of need that, which is why they use transition kind of ships with appending. But I was talking to Ricky, and he said that they literally they just put the pending state that comes back from use transition is just one of these, like exactly like this with exactly this, and that's how they basically model it. In terms of the code, if you guys are kind of interested in how this kind of stuff works, I can give a quick run through. The transition function is fairly straightforward. It creates a new transition, which is a kind of queue. If you haven't seen most Solid 2.0 stuff, you probably don't know too much about these queues, but it's basically a way of managing running. Like when it flushes, in this case, it sets the active transition. It runs the pure queue, and then it checks if it's finishing. And if it finishes, it actually runs the more effectful queue. But what's more interesting here is that the graph cloning. This is how it merges. It's actually fairly straightforward, funnily enough. If you pass in a node that already is associated with a transition and it doesn't equal the current transition, then go through the sources for the current transition and merge them into that existing transition. Basically, like just literally just add them to all these sets, essentially, and arrays, and then say that that transition is the transition, and then return the clone version for that node. And then here, the cloning, I'm just cloning the computation node, removing the disposal elements and the children, essentially, and then creating a backlink to the original node, and then adding it to our transition, and then going through its list of observers, cloning them, but also adding them to their observer list, which is important because sometimes the nodes don't exist in both places. Yeah, you don't really need to know that. And I guess the other fun part is what happens when the transition ends. Basically, if it's done, or it's scheduled, or there's promises, or all these things, you can't finish the transition. You have to wait because it's fine. It's scheduled, it'll do some work, and then it'll try finishing it. But then at the end, what we do is you go through all the sources, and if they're for this transition, not for this transition, or the source equals a clone or whatever, then we can continue. Otherwise, we remove the backlinks, those extra observers we have. We dispose of the original. This is when you finally do the cleanup on the original nodes. You assign all the new values into the source, remove the transition fields, and then once you've gone through all the sources, you set the transition done, delete it from the overall transition set, and then run the effects, and then reset all the optimistic updates. And that's that's basically it. I mean, I still got to do more work on it. This is very, very basic, but it's basically what I described earlier in terms of that. The trickiest part to the reactive system, I think, is that like in Solid 1.0, these should get tree shaken out because you can only set the transition in the transition function. But essentially, transition. There's a lot of hooks in that like look for if active transition. So this code should just tree shake or like codes like tree shake right out of the bundle if you don't use the transition feature. But there are a lot of places, not this one, this is the transition queue itself, where in the core of it, right, let me see if I can get to it. We have to do stuff like if there's an active transition and if this is a source in it, then get the source, otherwise use the original source. If there's like this is when we are creating computation, like a core like memo or something. If there's a transition, set the transition, set the sources. Like there's a bunch of these hooks. Whenever we read a reactive value, it has to check if it's there. If there's a transition, wait. So this code does increase over everything, but almost always it's controlled by an if active transition, and which is cool because if this can never be set to anything but false or null, this code will be just removed from your bundle. So at least that's good, but it does make maintaining the code a little bit trickier because there's a lot of these in place things because I don't clone. Even though I clone the sources, I keep the source side of the graph the same nodes as I mentioned for the reasons earlier. So there's a lot of touch points, unfortunately, which until we get I hit all of them properly, we might have some bugs, but that's generally it. It's doing what I want it to, which makes me pretty happy. Yeah, I wonder what happens if I change create effect to create effect. Does this just completely die? Transition already completed. Okay. Yeah, this might not be that hard to debug. Do you know what it is? It is delayed though. Interesting. See, I think what's happening. Yeah, that's interesting. Yeah. Basically, these nodes shouldn't be getting added to the transition. But I wonder if the fetching still is. So it's like in this weird state where it's like the fetching finishes and then it goes like, yeah, I bet you that's what's happening. What's happening is that create async registers with the transition. So it's like going to do its thing, but then it has no effects nodes. So basically the transition completes. It goes, okay, I'm done. Like you never see go depending here, right? But then when the async data comes in, it goes, okay, I'm going to continue this transition. It's like, yeah, you know what? Can we fix this right now? Create async. And transition to done and not done. Because if it's done, you don't want to do this. Yeah, okay, fixed it. It's funny though. What's funny about do you know why this works like this? Create effect doesn't tear. Only create render effects tear. Create effect actually doesn't tear, which is why it's holding. See how it's not counting? I just created svelte. Right? See, it's holding it in the past, including R39. So yeah. You wouldn't use this to render. This is logical. Like this is behavior. Like this is what happens if you block without transitions, right? But yeah, I mean, this is a good showcase, because if this wasn't rendering to the DOM but doing some other side effectful thing, like, you know, creating logs, this is what you'd want, right? Create effect is designed to be consistent, actually, um, and not use suspense. It's actually an isolated, consistent thing. This is what split effects give you. Split effects give you this great benefit of consistency. So these stay in sync with create effect. It's just that, you know, you don't want to block things. It's only within the scope, just because these are doing DOM operations, that it's doing that. Where I think the more logical behavior here would, you know, for rendering, like, let's go back to rendering, would be like, if you want to, yeah, if you're not using, like, if you're using transitions, good. And if you're not using transitions, there. But in no world should count ever stop counting, right? Yeah. As I said, there's a different. My opinion, and it could be wrong, but the thing that I've been working on with Solid is, I think that rendering and the UI have slightly different expectations than than like than like just normal effects. And I think the biggest difference here is that rendering the UI, you need to show that consistency, or purposely opt into tearing, or purposely tear, like, make a decision. Like, you have to make a decision on this. But the one thing that no one ever expects is for stuff to just freeze up on you. Okay, yeah. Salt says the mechanism not to block unrelated updates. From what I can see, I've seen it should keep the count running as well. Yeah, I believe so. I think it depends on how you write it, though. Like, I think you can entangle them if, like, it's like this, where you put it inside, like, the same text node. I think in general, though, if these aren't in the same effect, they're not going to entangle. Right. I did this on purpose to show it in the same effect. If these were not in the same effect, then count wouldn't freeze up like that, right? We're still using the graph to make this determination, and I think that's basically the gist, right? I think quite often these aren't in the same effect, so, like, Svelte's approach gets by most of the time, and that's pretty good, because when you have an, like, yeah, I guess. I mean, this is fairly reasonable. If we change this to create effect, right? And then, trying to think of how to make this work. I guess I can just make, like, a different. Trying to, like, think of how not to put this in the same effect. I mean, it's not. Count. I have to make div 2. Maybe I'll make it a span. It's just called count. It's like, what am I doing wrong here? Oh, right, I know what I'm doing. One fun part with split effects, the second function being a function. Okay, sweet. And then when I do it, yeah, it no longer freezes. There we go. So I guess this is probably the more typical Svelte behavior. And so, yeah, I mean, it's perfectly fine. And then they have a way of injecting within the scope of the components the pending state. So like this holds up to the boundary. As I said, I think transitions are global, so that's kind of odd, but I get why this would be attractive from an API standpoint. Yeah. Yeah, that would be better. I thought Svelte's approach is to compile animation CSS. Yeah, for CSS I do some stuff, but like this isn't really animations. This is state updates. I'm talking about an async data flows. Yeah. I imagine they're smart enough to know the graph relation. One of the biggest differences between the Svelte approach and solid approach for the async stuff is that our approach is completely runtime. We actually use the basically the throwing of promises to figure this stuff out. And I realized, and again, it was actually thanks to Dominic for when he was working on Svelte, he mentioned something. I realized that I'd already come up with a helper to see that get the previous value latest, that we could just make render effects wrap latest around this, and that would give us tearing back, which meant that but I mean, as you can see here, it's not hard with these things to model any of the different styles of behavior. I just I personally don't think holding as a default is as good, but I mean, it's hard to say. Okay, you made it for us, Dev. Where I got this go to my Twitch, which I haven't had opened all day, which is actually on me. I usually have it open so I can interact with chat better. My channel. All right, there we go. Yeah. Yeah, I mean, so this is graph connected. Now we just need to add a counter to this. This is from their docs, right? So then all we have to do is add a counter to this to do this, which shouldn't be hard. We should really go let count equals state 0, and then do something like set timeout. I'm not going to clean up after myself. Sorry, count plus plus. And then put count in here. Oh, it's not set timeout. I want set interval. Their timeout is a small delay, so I'm actually going to have to go faster than that. Yeah, see, they know that it's not, that it's independent. There you go. Yeah. So that proves that, and it's interesting because actually I want to see what the JS output is. Interesting. See, I was expecting count to get subdivided off, but it is actually it does appear to be in here. Which means they must be using some form of runtime in addition to the compile time stuff to determine the connectivity. Yeah, no, this is reasonable because basically they ensure that. I wonder if it's just simply because this update just runs the effect and it grabs the latest. Yeah, so I think I understand their solution. It's like halfway between a transition and not this. So this isn't quite solution what we created here. Like technically it works the same way as like the output is the same, but the difference for the svelte solution is they actually do fork the values in the signals so that when the effect runs here, essentially like when this effect keeps on running over and over again to do this counter up, it just reads the latest values even when it's in flight. So in that way, it's similar to the solids approach of using latest. The like our however, their version of latest includes the things that trigger the async. So it's like a mini transition in a sense. Yes, because the difference with the solid version is it doesn't include the state change. And the way they're able to do that is, my guess is that that's where the compiler part comes in. Let's take a look here. Like, how do they know? I mean, it could be done runtime as well, to be fair. Anyways, I not to get too much into the minutia here on the specifics here, but I understand the gist of it, right? The idea here is that they do almost something transition like in holding the values of the set, but they do so in such a way that I guess it's there has to be some element of it because they don't wrap the set. Like, where does the set happen? Oh, it's right here, this add. Yeah. Given that this is already in await, I think this might, or an async function, this might actually simplify things a little bit. It's curious to see what it would look like in a case where it's like a state set leading to a fetch, like a memo that's awaited, like a awaited derived value, and then see how they determine that. But yeah, they have to be using the graph shape to basically determine, because the reason you wrap in a transition API is because when you call a set, you don't know until you actually go to set it, like you actually call it, you go, okay, what are my dependencies? Like at that point you can go, okay, I know this is going to trigger async, but you don't know that beforehand, and you don't want to change it so that every time anyone triggers a signal, that you basically transition, probably. Like, because if every time you did it, that would be expensive, right? So that's why my guess, this is where Svelte ends up using the compiler a little bit, because if they can determine that ahead of time, then they don't need to use the wrapper. So that piece of the solution is actually pretty clever. Yeah, the two-way binding. Oh yeah. You're right. Like trying to scroll sideways. I was trying to see if like there's any indicator or hint that they would be dealing with something async here, but I actually don't see it in the compiled code, which is kind of cool. I was kind of like expecting something here to that effect. Anyway, yeah, I mean, I think this gets the result that they're going for. I think that the holding, when you can ensure this isolation, is fairly reasonable. The tricky part, obviously, is like the same problem you have with transitions. I say it's hard to make transitions the default API because people are like, where's my affordances? In Svelte, you can inject this back in, I believe, by using a boundary. But people are like, to be fair, though, do they have they don't have a localized reload? Can I get it here? No. Like I can trigger it by changing the code, but I kind of don't want to do that. Okay. Yeah, see, it would take a long time to show up. So theoretically, you'd have a boundary here already because you would literally be loading the code. Right, like, so it wouldn't be too hard to position in your stale state through. Yeah, this does remind me of a lot of what they wanted to do with Marco. It'll be interesting to see what they did choose to go with Marco when Dylan Piercy joins me on my next stream on September 5th and we talk about Marco 6. Okay. Yeah. Anyways, enough of this for now. I don't think there's actually much. Did I publish this one? I think this one, I actually covered everything already in the course of the stream. Talking about what single future means. Yeah. The trickiest part, obviously, with these pieces, and one thing that's very elegant about the React solution is the way that they've basically incorporated optimistic updates into the same model with the transitions, which is, as I said, valuable because then you can solve this issue as well. I think the runtime approach with the latest splitting is I'm still pretty big on that approach. But yeah, it is interesting to see different models at play. Okay, where did I want to go next? Sorry. Talked about this. You know what? I mean, that's pretty much the transition topic. I might as well do a bit of this week in JavaScript because we haven't done this in a while, but give me 2 seconds while I sort that out. Okay. Oh, I just saw a comment. Use RxJS to handle concurrency. I think you can. And I've been getting a lot of RX comments like on my Signal streams. The challenge is, I mean, yeah, use events because they are streamlined. The problem is about these async models. It's never the actual managing of the async. It's getting the async back into a synchronous system, one where there's guarantees in terms of what you show up, and like show up in terms of the UI. Like so. Yeah, let me see. When was my last stream? It's funny. There's actually okay, yeah, I covered the Rich Harris thing. My last stream would have been on July 25th. Okay, cool. Okay. And okay, give me 2 seconds. How's chat doing? You guys alive? Quantum programming. Yeah. Yeah, has React just pushed their complexity on everyone else? I think about this stuff all the time too, because it's like, is there simpler models? But it's like, not if you define the baseline, to be what it's. God, there's so much stuff. By so much stuff, so many interesting Brian Florence and Michael Jackson tweets to talk about. No, all right, 1, 2, 3. I'm good to go. Let's switch modes to This Week in JavaScript. That way I can get back to programming. Yeah. Let's get going on this. I'm gonna start with. I start with solid stuff. Yeah, probably because it's just completely off the side of things. I've been loving the TanStack stuff. Me and Tanner did a stream recently where we talked about some solid and TanStack stuff and RPCs and server functions. But like, it's so cool to have a framework ecosystem and one of the largest ones in React to have solid as the second citizen, right? A lot of the times, a lot of React frameworks and stuff don't cater to other frameworks. Like when they release something, they don't immediately release it for another framework. And if there were ones that were fairly fast at it, usually Angular and Vue get the next nod, and then occasionally Svelte. But with TanStack, Solid's number 2, which means that like for once, like all the new cool stuff comes directly to us. So it's like TanStack DB comes out for React. A week later, it's out for Solid, which is just awesome. So like this has been good. Obviously TanStack dev tools and stuff have been written in Solid, like very close to that team. Tanner is amazing. I love the work he's doing. He does the stuff that I don't care to do. I focus so much on these like really low level primitives. Someone has to make the developer experience pleasurable, and hopefully I'm building the right stuff for him. But yeah. TanStack and most of the sync engine community is treating Solid as second-class citizen. Yeah, they should, because the stuff we've been working on, I think, makes it actually a better solution than React. We just, we're not React, so you have to support React first. But it's kind of like this. I remember when Jamie from Convex first saw Solid, and he went off on a tangent. He made a YouTube video and made a Convex integration and did this all in Stew. And his team had to like pull him back and be like, "Look, we got to focus on React right now because we're trying to raise and go to our next stage or whatever." It was like 3 years ago, I feel like. But anyone who's working on a sync engine, they see Solid and they're just like, like they're like, this is the UI framework that makes sense for us. So yeah, I mean, yeah, it's exciting to see this kind of progress, right? And it's been part of this like, yeah, solid and terminal HMR. People are just starting to like understand like the things that React has been having a hold on the ecosystem was like everyone's like, oh, with a virtual DOM you can do things that aren't the DOM, or you can go into these different kind of scenarios, and it's like, you know what, you don't need a virtual DOM. Getting over that hump has taken like a decade for people to recognize it, but it's starting. Yeah. But yeah, this is what I mean, this growth has to be thanks to TanStack and um and uh and the sync engine peoples, because like this doesn't look like very impressive. You're like, oh, this is a fairly flat line. You know, it's 6 months, you know, but it's because I've stretched it. 300,000, 710,000 or something. We've over doubled the amount of downloads in the last 6 months, which, as I said, going up 300 and some odd thousand isn't a big deal when you consider, like, you know, most frameworks get millions of downloads a week. But doubling in that short period of time when we have not done a major release, no new features, no, like, literally nothing to merit this kind of growth, is incredible. It means that people are starting to catch on, right? Like this is not because like, oh, you just dropped the Solid 2.0 release or whatever. This is just people picking up Solid and going, yeah, this makes a lot of sense. You know, like it's funny because when you do npm trends, you can like see it a little better than my graph. I just didn't want to show the history because we flatlined a little bit, but if you go here, because like the last year doesn't look too impressive either. You're like, okay, because it's stupid spike. That's why I didn't want to show the trend. See, every framework has these stupid spikes that happen, and you're like, how the hell happened? But let's look at the 5 years to give you a better idea. Yeah, here we go. Or all time, yeah. This is more indicative of the growth of the last 6 months. This, you know what I mean? 2024 was tricky. It looks like we had a like solid start, came out around here, so we had a swell, but then it almost returned. Like basically, solid start did not perform as well as, you know, I might have imagined it would. It kind of, even though like humped up and looked down, make it look down, for the most part, we just kept the same trajectory when you average it out. It just, the growth was constant. Solid start didn't end up adding much to our user base initially. It just kind of kept the same trend line that we've been on since about 2023, which is, you know, a decent growth pattern. But then the last 6 months, like, ooh, you know, suddenly that makes that trend line look like exponential instead of flat, which is good. It just, the stupid spike in the middle ruins everything. But to be fair, if I put Astro during the same time period, they probably pulled away from us. Oh no, I guess we caught back up on the Astro thing. See, traditionally us and Astro have been very close, probably because a lot of the same users. And then Solid Start jumped it a bit, and then we kind of went down a bit, and then Astro was the thing. But then we're back to basically neck and neck with Astro, which again isn't a competitive thing because us and Astro do different things and do the same things. They're actually very complementary. But yeah, I mean, definitely TanStack using us and fixing it so it actually showed is actually probably a good sign. It's supposed to be a starter. I'm trying to. My plan for it was it to basically be our version of Create React App, but modernized using Vite and using like SSR. So yeah, I mean, yeah, it's been good. Dax, this is your comment about the whole, you know, that whole scene. TanStack. I mean, that's all the news. More DAX stuff. TanStack. Yeah, I don't know. That's all the solid news that we've announced. But I actually do have some solid news that I want to talk about a bit. We've got some, and it'll come out this week, so I'm kind of ruining it a little bit. But we got some new fellowships coming in, and most importantly, we have a newest member added to the Solid Core team. Achilla Facina, you've seen him, on the stream before, doing the Tory stream with us. Great public speaker, has done tons of solid JS talks. Head of our DX team. He's actually stepped up to kind of lead the efforts on Solid Start, which is great because I have not been focusing in on it all. And we've actually got sorry the pun, pretty solid team now. It's funny, I know everyone by their usernames like Brennels and Brendonovic or whatever, but Kasha's on it too. Like there's a group of them that they've that have been doing a lot of work on Solid Start. More specifically, when I have not been able to focus on it, and they've been heading up like the Da Vinci, like removing Vinci effort and modernization, getting on the same bones now as TanStack Start. They've been obviously working a lot with the TanStack people, anyways, help like getting the solid integration of TanStack as well. So it's really awesome to see these this kind of coming together in an official way. And Chilla has just done amazing work for us over time, and it was long overdue for that. So the announcement should be coming out soon. He'll be, I believe, he's going to be coming up speaking at BeatConf coming up, I believe. I haven't heard too much about that. I haven't actually looked at the site recently. So yeah, very, very excited about this. Solid JS is solid frame. I'm surprised it's taking this long to take off. Years of head burying into React. Yeah, I mean, it's just one of these things. I mean, don't get me wrong. It's not even taking off. It's just steady growth. It's really hard when the stuff is so grained. How is Solid for full scale enterprise web app? The client side part of the solution, like not the Solid Start side of the solution, has been pretty stable for quite a long time and pretty solid. Obviously 2.0 is coming out, which is probably the first considerable change in 7 or 8 years. Actually, you know what? There's a tweet here that I skipped over that I think we should talk about in regards to this thing, and you decide, For a framework renowned for its innovation, it is funny how little Solid has changed in the last 7 years. Yeah, we've innovated on features, fine-grained concurrency, hydration, streaming, server functions, single flight mutations, but the core tech and structure untouched. And it's true. I forget, I was doing a podcast or something, and I was like, I sometimes forget because we're always, talk about signals, but we've actually been at the forefront of a lot of stuff. Like we were the first one to do like transitions with the signals, or like these kind of async models, right? Fine-grained hydration did not exist before Solid, right? Like people didn't coarse-grained hydration. Obviously, there's better versions of that arguably today with Zoomability and Quick, but streaming. Marco was first technically. So there's that, but other than that, Solid pushed forward and was one of the first frameworks to do streaming other than Marco. Server functions, that was something that we worked on during Solid Start. Blitz technically had like some kind of proxy, I believe, based, or like they had an approach to doing RPCs, but like the modern server functions started in Solid Start. Single flight mutations was us Solid Start. But through all of this, we actually haven't, like Solid hasn't changed pretty much at all. Like we haven't changed our templating language. We haven't changed our reactivity model. We haven't, like what I say, when I look at React, Angular, Vue, or Solid, the same campus data, even when backwards compatible, they've changed their structure underlying text significantly, at least 2 times each. This is a hindsight observation, but one we could have banked on ahead of time. Like I knew. And what I mean by that is like, I knew what I liked with Knockout, so I just went in with that kind of mentality. ironically, split effects are probably going to be the biggest like conceptual breaking change for Solid 2.0. But my original knockout wrapper that I had at my company had split effects back in 2013. Like, it's just one of those things where, like, anyway, part of this is we bet on old tech. We didn't try to use classes before they existed. Yeah, so switch to real classes, decide functions were better, then add a compiler to fix. Okay, I'm clearly talking about React here, but like, because people talk about React, and not changing and stuff. But while it's been backwards compatible in a very impressive way, considering how big the scale is, if you like, yes, React hasn't changed much in the last few years. You can say RCs, but RCs don't actually change React. They're like an additive feature, perhaps. I mean, the async features, I could argue, changed it's significant, but for the most part, I could see an argument to say that React hasn't changed much recently. But let's look at the first 5 years, even, or most frameworks, when they're trying to find their footing, have actually changed as they figured these things out. Right? Create class, or React, create component or create class. I can't remember. Basically, they had one class and they had actual class, like extends component, which wasn't a huge change. But they had to remove mixins, right? When they made that change, then they switched to functions with hooks, which again was another API change. And then the compiler, to be fair, isn't actually as big of a change. I could argue that it's still just hooks continued, but it is enough that it, like, of a kind of a API surface level change, right? And part of this is because they tried to use classes before classes were prime time. So I get why, but that is one of the challenges when you're coming out with something new and you can start new. You don't want to start in the past. You don't want to like assume, like, take this clunkiness. You want to jump ahead, right? React's done this a few times over years, like force async local storage when it doesn't exist on the platforms, stuff like this. But sometimes that leads to, API changes when you realize other stuff ends up working better anyway. Okay. Nor did it start with no VDOM, then switch to it, and then switch back again. I'm talking about Vue, right? Like, and Vue also went from option API to composition API, right? They actually, Vue 2 to Vue 3 was a fairly big change on an API standpoint. They basically changed the whole way their rendering worked a couple times under the hood. So architecturally, it was a different framework, right? And then, I mean, Svelte had Svelte 1 and 2, Svelte 3 and 4, and then Svelte 5. So they've had basically 3 versions of Svelte over their first 7 years, which is good because, like, in a sense, when you change and you increment, you learn stuff and you move on. In a sense, Solid hasn't changed since 2018-ish. I mean, 2019, I guess, when I switched to the tuple thing. But even if you forget if you replace the array destructuring with like get or how did I used to do it? Yeah, it was like, I think it was .getting.set or something like that. Essentially, Solid had the same structure of app and the same technology approach since before I even released it on the server. Like, going back to, I guess, the biggest change is when I changed to JSX. So end of 2017. Solid hasn't really changed in a fundamental way in about 8 years. So, like, I don't know. It's interesting to me because we've been working at this thing and everyone wants stability. Everyone's like, oh, blah, 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 and ecosystem and all this stuff. I mean, I'm also saying this knowing that there will be a couple breaking changes coming in 2.0, but, like, from that perspective, while continuing to push the boundaries, we've done all the right things in terms of being stable for our users. Like, to a point that there should be no expectation for us to be even stable even longer necessarily, because in the same period of time, every other framework has switched what they've done like 3 times. And I was trying to, like, think why this happened, right? Instead, like, Ricky was like, do you think it was prior art? Do you think you like, when you looked at other solutions, that helped you avoid stuff? And yes, I spent a lot of time looking at other solutions, but it's not even the solutions that they've created. It's the solutions that they could create. And I feel like it's because you know, focused early on mechanics, looked at the best way to solve a problem, and then interpolated back, right? Sure, it isn't an approach without faults. You know, made plenty of mistakes, and there's a lot of things about 1.0 I don't like. We just avoided some fundamental ones by curbing ambition and focusing on engineering less on the developer, right? It wasn't like just chasing like, oh, what's the least number of characters you can type here? It was like, what's the best way to do this? And then let's figure that out, right? Because if you start from a place of performance first, you can usually find a way back to something acceptable, hopefully. But if you start from a place of like what you would like to write first and then kind of get there, you can't always make the performance. The shape of the API can actually limit what you can do. Hey, Shai, it's been a long time. Although it does require a certain amount of success to recognize it's impacting your mistakes, so we might be seeing benefits from lower adoption. But yeah, I'm just, it was just something interesting. I wonder if, you know, something about Solid is innately characterized by these characteristics, and it's something that we can actually codify into like our values to make, you know, Solid the type of framework it is. Like, sorry, I didn't even talk about Angular here in terms of change, right? Angular 1 to Angular 2. The switch to Ivy, which is a completely engine change overhaul. I mean, these things happen over time. Not, you know, Solid being later to the game does have a bit of benefit, but when it's been longer now since Solid was introduced than like the time period of all the churn of the frameworks that, you know, people talk about. So this whole like, you know, yeah, it's very difficult to, you know, look at the argument against stability, and like it becomes increasingly difficult to make the type of arguments people have been making against us as time goes on. It just they look very out of place, which is why maybe that's why the growth with no releases, the growth has been, you know, doing so well. It's just like maybe eventually you get like hit over the head with a sledgehammer enough times, you kind of go, okay, fine, I'll wake up, I'll take a look. Oh, you're right, I did. When did I remove my screen? That's funny. Ten minutes ago. Oh, did I not have it like the whole This Week in JavaScript? Okay, just before I start reading this thread. Okay. Yeah. The truth of the matter is things do have to change. I'm like the first person to say like if things, you find a better way to do things, change. Like this is the most ironic thing about this. I am not adverse to change. When React pushes these boundaries, changing things, I respect them incredibly for finding ways to do that when they're the incumbent. Like I'm the first person to push for change, and yet somehow we've just managed to be in the right spot. You know, I don't think we'll forever be in the right spot. I think things do change. We somehow managed to find, like, I don't know, is that what people call it when you're like 5 or 7 years ahead of your time? Like we just found the pocket, and now things are finally catching up to where we were 7 years ago. So it's easy for me. This is probably one of the last times I get to make this kind of statement. Do you know what I mean? Because stuff will continue to grow. We just happen to be, you know, ahead of the curve in such a significant way, but like also not like appreciated or noticed for it. So like because we didn't have the adoption, it like perception. As I said, how much of this what I'm talking about is just perception, right? And luck, because like how likely are you to, you know, come up with a solution that everyone else ends up doing? I don't know. Like, and then at the same time, don't get adopted on your own merit yourself as much. Like we now have much more popular solutions taking the approach that we were doing 7 years ago. You know what I mean? Like, or 8 years ago. So it's like, it's kind of funny. break the API, you break the existing apps project, and you never break user space. Do anything else you do to announce here. So yeah, this is the thing is like, there's a difference between say breaking changes and like React has done, for example, a very good job of not breaking. But to be fair, I guess I don't know how Vue and Svelte have done. I guess Svelte, you can still use Svelte for components, but when they moved to Svelte 3 from 1 or 2, I don't know. Like you can be non-breaking, but still change everything, which effectively been breaking. I think this is one of the challenges with the UI frameworks is like if you so drastically change the way you actually use them, you can be non-breaking, but yet at the same time completely change like how anyone would write it, to the point that the old code is basically not maintainable anymore because no one even knows how it works. So it's Python. I mean, sometimes those changes are necessary, right? And as frameworks and tools mature, they should be changing less. I mean, the truth of the matter is, Solid hasn't done 2.0. Like we have like Vue had 2 to 3, Svelte had 2 to 3, and again maybe 4 to 5. We haven't had 2.0, so I recognize that. It's just if you look at something for 7 years and go, yeah, actually 95% of it was actually the right call. I mean, that's a pretty decent place to be in, like over a 7-year period. But yeah, it's just funny because like you'd hope something like this, you know, I'm not saying this, I agree completely, but you'd hope something like this would help, you know, encourage people to, you know, do something. And it's like over the exact same time period, you know, yeah, people have switched with their favorite tool like 3 different times, you know, how they write stuff, to now the point that they're basically writing the same way they'd write in Solid. But they wouldn't just have changed the Solid in the first place like 5 years earlier. There's a bit of irony in it, but it is what it is. Yeah, I mean, most frameworks have been good on a migration path. I'm just saying, like, conceptually, it's still churn if you effectively end up having to rewrite all your components. Like, I don't like. Yeah. It was just something I noticed. It was, I mean, this is just like one of those hindsight things, because like you watch where you sit there, like I can still remember sitting back to where I was when I was first like doing Solid by myself, like 2016, 15, 16 period, playing with stuff, and how I looked at the ecosystem, and then how I built the thing, and then compare it to like now, you know, like as I said, almost 10 years later, and just like it's kind of unreal to see this kind of change or switch over, and you're just like, huh. Makes you wonder how things could have been different. I don't know. Anyway, that's enough Solid stuff today. What else do we got here? Okay, yeah, this is good. I forget why I wanted to do this. This is probably subtweeting something that Ryan Florence said, but I probably don't have it anywhere. Maybe someone else's. Okay. Suspense activity and other boundaries are fundamentally different than concurrent transitions. Boundaries are read-centric and local. They care if and when something can be rendered. Transitions are write-centric and global. They enable transactional state updates. I'm kind of stepping back from the whole transactional thing, but it makes it easy for people to understand. The reason the lines blur is that while transitions wrap from the right, the indicator of completion is still based on read. So the state of boundaries can impact their completion. However, they aren't interchangeable and cannot be completely replaced by each other. Yeah, this is still talking about people trying to remove transitions. I think our whole stream today basically covered why this is the case. So I'm not worried too much about this. All right. This Ryan Florence tweet. Seems like if we went all in on Canvas rendering, the web would be so much better. It's a clean start with the HTML DOM being requiring a whole new platform. And it's not fundamentally impossible to make Canvas accessible if everyone is on board with it. And I think people misunderstood my quote tweet here. This kind of thinking I can respect. I can't comment on viability, but which I want to stress, I can't comment on viability. I'm not saying that this is a good idea. I'm saying you have to challenge the assumption if you want to enact real change. We tend to not get to significant places by incrementing alone. You have to throw something out, move a step backwards and move forward. And I actually think that the Remix guys are one of the best teams or groups of people at doing this. I've been critical of them times saying that they move 2 steps backwards, 1 step forward, not 1 step backwards, 2 steps forward. But to be able to move 2 steps backwards still requires and understand how to pivot like that to be able to move forward again is a skill in terms of itself. This is a legit argument, and I was actually kind of laughing about it because this was actually my reply to. This takes not being afraid of where the train of thought leads you. Come up with an outrageous position and then try to take it to the extent. That's why we have the VDOM today. Not all ideas at work are worth it, but I'm glad to see the thinking get here. And what I mean by that is if Jordan Walk hadn't come up with an idea that conceptually was kind of crazy, like basically the virtual DOM, if you think about it, is a terrible idea. Like you're just like, why would you just do something worse, right? And yet it's worked so well for people over the years. It wouldn't happen if people weren't willing to challenge and go, I wonder if this is good enough or if this will work. And it was funny because Ryan Florence did this thing. Components are awesome, but not enough. Hooks or compose are awkward. Signals are this tweet. I read it and I was just like, this is kind of crazy, right? What if we didn't track something? What if better stupid? Like, I don't think. I mean, he asked some good questions, but I don't think there's actually an answer for this that's reasonable. So but I'm like, okay, let's think through this. And by the end, I was like, basic DOM is execution context unless you're talking about rendering to canvas. That's pretty interesting. Basically, if you follow the logic, you might get to a place that you don't expect. Because basically, to solve these, the reason we have these problems is because of the shape of the DOM. Otherwise, you can probably come up with a solution that will make some other trade-off, maybe in performance or something, and be happy without these, but you're not going to have one as good, right? And it makes it interesting, right? Because like every framework or tool has its own kind of angle. And in the case of SolidGiz, no, I initially and continue with the team focus on mechanics, on performance, on like architectural considerations. So when I see these lists and I'm like, yeah, this stuff's all necessary, to be able to kind of, because of the performance stuff, to be able to throw it out and start again takes incredible amount of like pulling it back, which is what I was going to get at. Like, I don't know. Everyone in the comments was like, this doesn't work. We've tried this before. It fails. Okay. Yeah. I'm not commenting on viability, but it takes being bold sometimes to be able to change things up. And most of the time it's not going to work. Like 99% of the time it's not going to work. But that 1% doesn't happen if no one doesn't do this. Yeah, well, I mean, yeah, actually, sorry, Deb, I like this argument here because if you change your state, like the portability of your state actually matters like a bit on signals versus not, like once you have signals and you want to use signals in other components, and technically you can use them in your SOL4 components, but once you start translating your state into the state management, then you have to go update those components, at which point you probably should change them to use fine-grained rendering rather than SOL4 rendering. So it's like, this has cascading effects because not every part of your app is independent, especially when it's about data dependencies and stuff. It actually changes the patterns considerably. I think the same thing is going to be true of Vue Vapor for the fine-grained rendering. Like that one's a little bit more isolated, but like these are big changes that, it's hard to know until you like get in there, and it's always the hardest part. Yeah. It's funny how standard almost nobody questions it. Yeah. I forgot people came up with it. A legitimate, like you have to, like sometimes it just works, like sometimes you just hit the right thing, anyways, yeah, still waiting on this. Super stoked for the Veet documentary. Oh God, I forgot how much cool stuff I have here. God, we went through a lot the last few weeks, eh? Sorry, this one's solid. Am I on my page? Yeah, I'm on my page. I'm like, where's my bookmarks? One of these has got to be bookmarks. Oh, here it is. Yeah. Yeah. I mean, I coined JavaScript fatigue. So I just bookmarked this because I needed to see the guy who coined JavaScript fatigue, if this is actually true. Because this is the most. It's true, but it's also been like my biggest enemy for like 8 years. Um. Oh man, there's so much good stuff here that I've missed. Yeah, I mean, I don't believe, I remember reading the original article, 2016, 15, yeah. Yeah. Yeah, and it's funny. It was relating to React changing anything. Yeah. Here's your ascension. Yeah. Oh man, this is a classic. Thanks for sharing that, Dev. I was trying to find this the other day. Oh man. Sorry, I know I didn't put that on screen. That's fine. I mean, I could put it on screen for people who want to see it, but the article itself isn't very long. It's just like it's like a conversation. It looks like some of the old images are gone, probably because the React core team decided to delete all their posts on Twitter. So they don't realize the impact of that. It's fine. I'm still choked about that. I know it seems dumb, but like these social conversations become a fixture of like the history of these tools in the internet, and it just to remove them is just anyway. Where do we want to consider thing? Like there's so many different ways to go. I guess I just pick one. We're done with solid. So solid. Am I done with solid? Yeah, solid. Done with solid. Okay. All right. Angular has been working on deep signals, like apparently I don't think I want to look at the code here. I think what I wanted to do was see people talking about the proposals, because I think someone like Manfred was talking about like how stoked he was about about the approach they're taking, because they're using something kind of more path based than the way that we're doing with the nodes with the stores. The danger here, I think, yeah, they have almost like lenses. I wonder if I could find the API for it. It'd be easier to talk about it. I think the challenge here is you want to make sure when you have deep stuff that every time someone reads that property, it is done in the deep way. Because if you split between the deep and the non-deep approach, you're going to end up with weird UI tearing, which I think is my biggest fear of this approach, of just basically kind of like having these kind of lens like wrappers into the state. Because if you can access the same values without them tracking deep and also with them tracking deep, you end up in a weird like duality place where stuff can get out of sync with each other, essentially. Because some things will trigger updates and other things won't, when something changes deep, it should always trigger the update of the thing above it. In certain scenarios, there's places like when you have storage where you go, I want to trigger the deep thing, I don't need to notify the top level thing. But if you can listen to the top level thing, then you expect to get have the latest value and actually have it trigger. Like, it's kind of like on you. I'm gonna have to see more of this in motion, but what I saw so far did leave me a little bit concerned. I think I get it, but it is definitely a different direction. Talk about those. Yeah, talk about those. Okay, let's go back here. Okay, this one's just a novel one I want to throw out here. I was talking proxies I've been looking at for hydration, which is kind of cool. Are they just renting models? Sorry about the Angular thing. I mean, we all had to reinvent it. Views, reactive, solid store are basically the same thing. The API services are a little bit different. But yes, I mean, we all need deep reactivity. It's a whole classification, I think, that's underexplored, especially on the drive side. That's why I've been focusing the last few streams on this. But yeah, I mean, there's a lot of devils in the details, and I do think there might be like a generalized solution of what these should look like. Like, the trickiest part is as you move further away from the core of this stuff, it's easier to diverge and have different opinions and just like different types of solutions. I do wonder though if there's some fundamental truths here to be understood. Anyways, sorry, this example was fun. I was sitting there and I was like, I wonder if we can like create because with hydration, we could create an element before an element exists with this like idea I had using a proxy. So someone had a proposal for Solid for like create safe ref, which didn't really fit Solid semantics, but I looked at it and I was like, because they were like basically making almost like special helpers that would wrap like a function that would trigger when the signal and the ref updated. And I mean, I got what they're doing. I've seen stuff like almost like solid hook forms and stuff like that use a similar kind of almost approach to handling their internal refs. But then I was like, well, what if we just fake it? Like, create a proxy ahead of time for something that we're going to set down here. But until then, we can, add an event listener to it, set a value on it, console log a value on it. This return a promise thing is kind of interesting. I'm not sure this is the approach but basically I didn't make this. Mizulu or Zulu on our Discord like basically heard me think out loud and then just made this demo, and it just looks cool to basically be able to wire the stuff up before it even goes. And because solid components don't rerun again, this is perfectly valid way to do stuff. You basically are just setting a bunch of stuff on the proxy, which you store. And then when the actual mount hook happens, like when it mounts with suspense or whatever, whenever it happens, or show, he's using show to show the timing coming in. It's only at that point that it actually can resolve and sort all this stuff out. And I mean, cool, that's all I got to say about it. I don't know if I'd go all as far as doing this, but this is the kind of thinking that we have to do, when I'm talking about thinking about outside the box and trying to push stuff. It's like, if the shape of the problem doesn't fit what you're doing, like, rethink it. Like, if refs are awkward, maybe create them ahead of time, like the other thing reason I like this is there's no create effect here, right? Like, I've been playing this kind of game of like, how many ways we use create effect can we get rid of? Because on one side, I think I've kind of tried to show, and I think it was actually kind of obvious today with the transition stuff, why effects need to be split to actually do what we want. Like, they kind of have to be. But then it's like, can we avoid using create effect? Like, is it just like our effects, should they be for something very specific, like for side effects of your system? They definitely should be for syncing safe state. Maybe you don't even need them for managing DOM refs. You know, like maybe there's a better way that effects are literally for stuff like logging. You know what I mean? Like, we know that we don't need them for async. We know we don't need them for, you know, a bunch of other things. So interesting, nonetheless. I'll paste this example in case anyone wants to look at it later. Okay, just double checking something here because we talked about all of this stuff. Okay, yeah, so my last technical topic is about the browser. Before we get to that, let's look here. Let's talk about React for a moment. It looks like React, the good parts: components, composable building blocks or UI. JSX markup uses JS language extensions to have bespoke template language. Virtual DOM, render everything, let the runtime figure out. I don't know if that's a good thing, but let's say it is. Rest, sometimes you need input.focus. The okay part. See, I view this as like the good, the bad, and the ugly. Because he calls them okay, but context, synthetic events, okay, that's fine. These are actually okay. The style prop. Yeah, I guess it's a special case. Class component lifecycle methods, mostly deprecated now. Yeah. Effects, workable but foot gunny. Bad parts. React owns your states, re-enters couples of state changes. Okay. But that is the virtual DOM. I mean, unless you want your users to call update themselves, that is the virtual DOM. Or you're like doing some kind of polling system. Lines are blurry around what state is versus refs. I agree. But that's because of the virtual DOM, again, because of re-renders. Rules of hooks or rules. Yeah, how is the virtual DOM not the bad part here? Like all his bad parts are an extension. Like, okay, okay, fine. You don't need hooks if you have the virtual DOM. Like the virtual DOM doesn't mean you need hooks. So like the VDOM maybe is in the okay part and the hooks are the bad part. Bundle match or other full set modern feature. I mean, it's server rendering. Yeah, I mean, it's tricky. I feel like SSR is the main reason for this, and there just isn't isomorphism is actually the main call for it. Like you don't avoid this. It's not like remix isn't bundler magic either, right? Like having magic exports is definitely bundler, like loader and action is definitely bundler magic. So I don't know. I feel like bundler magic is like the okay part. It's like a necessary evil. Like I think everyone recognizes that at this point. But I do think this is an interesting way to break it up. Because components are great. I think JSX is great. You don't need refs if you don't have the virtual DOM arguably, but yeah, refs are pretty. They're okay. They're pretty good. I think your refs might actually be okay. Context is kind of interesting because I think context in fine-grained systems is a good part, whereas in React it's a mediocre part because you can actually put state in it and like all your third-party state solutions can work with it. Like you can't use state in context without like it kind of, you have to bring your own management in, but in like a signals library you can. Synthetic birds merging user probably gets ugly. I agree, but yeah, this is definitely on the side. Style prop, yeah. So yeah, I don't know. Class components, right? As I said, they're not gone, but they are basically. So yeah, I think that's an interesting list nonetheless. I do think it's funny how many of these things are related to the virtual DOM though. Let's see another one. Functional programming is absolutely correct. Logical way to write code. It was discovered like physics rather than invented like social science. Yes, which is a good characteristic to have. However, only people with socially ability can master it. Best needs social science. That's a fact. Or what's a monad? Or effect. Yeah, he's like, I remember introducing use effect on the world stage. Purity over pragmatism, and then try to force on other languages. You don't need to really intellect to master Erlang, Elixir, or Camel. Like, this is all positioning stuff, I think, for the walk away from React. But I like the engagement they're getting on this. It's interesting. What else we got here? I'll get back to that one. Hi, I have thoughts. The short answer is app router is easy, but not simple. It's easy to get started, but complexity ramps up fast. I've said this previously that if you don't need streaming, then the app router might not be a good fit. Why is the site slower on the app router? Okay, let's see. I've wondered. I flagged this one because Lee doesn't work at Vercel anymore. But he still decided to kind of talk about like the trade-offs here, and app routers apps have hit some impact. I wonder what his perspective is. You know, maybe it's slightly different now that he's not there. Here's some random complexity ramps. What React transitions are and how Next.Router uses them. Okay. We talked about transitions today. How streaming rendering works and why Next.js apps are designed to word them, like generate metadata. Right. Okay. Because it's tricky because you have to hoist the. Yeah. Okay. Like the data fetching, the hoisting, and the timing is tricky in order to get streaming to work in the right way. I see what he means now. How dynamic rendering affects different prefetching configurations. Yeah. I do think PPR and stuff add this extra layer that makes it even more confusing. What RC play and how to optimize it. Why server actions are unguessable and encrypted URL endpoints. I don't think that's a big deal, but yes, it's a good point. Why use client is actually a bundler feature. It is, yeah. It has to be. This is kind of something we talked about. But bundlers are actually kind of essential, which is what Ryan Lawrence's or Mike MJ's, I can forget which one of them complaint was, but we're getting kind of to this point where like you can't solve this just with a compiler. That reading search params, because like you might not, if you have code splitting involved, sorry, just to clarify, you might not pull, like things have to exist on the client and the server builds from a whole graph understanding perspective, not just like as you hit them. So it takes more than just changing the code, because you also need to have the code that registers the code that and links it back together. Reading search round takes your page dynamically rendered. Yeah, I guess that magic stuff. Most of this complexity comes around is that the app router is designed almost to start from like, I'm building an Astro site and then scale up from there. Explain where the central complexity, step back and ask yourself whether Next is the right tool for the job. Many times the answer will be yes, how I'm building Next app router, but other times it's no. Next is with Army knife. Sometimes you need the really sharp single purpose knife. Yeah, that's tricky. That seems tricky. But yeah, I don't know if I actually have as many thoughts as I had. I just marked this because I thought it would be interesting to see what he thought. But yeah, I mean, takeaways, sometimes it's tricky to have an easy to use but general tool. You know, when you make stuff flexible, it's different than making something adaptable. It's one thing, like you can keep things simple and you be able to use them a lot of different ways, which I consider being adaptable, where being flexible is usually involves like having config or having like lots of different modes something can work in, but hides that, basically hides the complexity from you. It makes it easier, but it doesn't, you know, make it simpler. I bookmarked both of those. We'll get back to that in a minute. Actually, you know what? Let's talk about it now. We've been talking about a lot of Ryan Michael stuff because it's interesting. Sorry, it's funny because I said I probably wouldn't talk about the stuff on stream, but when you're building a framework, you end up in these weird zones where you're like, can I do this thing a little bit differently? And I relate to a lot of the tweets when I see them. Whether I agree or disagree is a whole other thing, but I actually see a lot of these tweets and I'm like, huh. But yeah, this is a funny thing on AI. Ryan and I are barely writing any code ourselves for Remix Tree. It will be the first web framework that is almost entirely written by AI. I read this and I was just like, this is batshit crazy. I can't picture it, but maybe I'm not that AI versed as you guys saw in the last stream. It's interesting. I started like asking myself a more general question: would I trust an AI to write my framework? And I mean, the answer is no, because like generally my experience with AI is it caters to the lowest common denominator, which means you never get the best thing. You always get the reasonable thing. I think when they say it's written by AI, it's like the previous version was written by VS Code. Oh, okay. Let's see what. It's interesting. Maybe like if I was doing like solid star stuff, I could see this because like I don't write my like you can actually almost see this like in the repo. I don't need to turn through a bunch of code when I'm most of the time when I'm working on solid. Like the signals thing is like less like when I put the build output out, it's less than 2,000 lines of code, right? And I've been iterating on it for like a year. Like, I'm not doing a vast amount of code. I don't need to like churn through this stuff. Every decision is so critical. Every piece requires like weeks of thought, right? In terms of how they all work together. Like I'm not being bottlenecked by my ability to code fast. I'm being bottlenecked by my ability to think through problems and finding solution. Right. I mean, there's a different thing about AI failing to to work with not being great with certain types of things. Unless you're saying, okay, it's something else about AI working on libraries. Like, do you mean like using AI to work on libraries, or AI not being good at generating code for certain libraries? Yeah, it seems to fail with libraries specifically. Yeah, I'm more talking about like picture you like I'm writing my like solid signals, Yes, signals, and I'm working on this code base with AI. It's like I just can't. As I said, I'm never limited by my this pretty much ever by my speed to code. It's not even generally by my speed to implement like ideas. It's more of like you implement and then you go, oh, this was the wrong idea, and then you're like, okay, I gotta like do this again or refactor this out. Like so, it's like I when I read this, I'm just like, what are they building that this would actually have any kind of impact? Like any. Like I was like thinking like there is it's not like you build a lot of features and that require a bunch of code. Like when you're building product and you like you have a new section of the app and you're like, okay, crap, I need admin sections. I need to manage that. I need like all the features. I need this view, this, like I got a light box here. I got like modal pop-ups. This can flow, maybe a wizard, simple view, expert view, there's all these kind of considerations when you go like, I'm adding this feature to my product. Frameworks, generally, the pieces are much smaller and they're all integrated. So like, I don't end up, when I add a new feature, I rarely ever, I end up adding like one function and then editing a dozen other functions in different places, like a one liner here, there, and then sometimes goes, oh, actually I can't do that, and then like pull this thing out or something. But it's not like the amount of code that changes is so minimal comparatively. Docs, yeah, I can see that. The critical part is code. You're definitely not going to write with a code. You're going to make it persist updates or use completion. But like everything, I feel like everything I do is critical. I know maybe I'm just view myself too self-important. Yes, yeah, tests. God, AI and tests have been my best friend. But I won't. You know what I mean? Tests are amazing. It'll be first one that's learned by AI. Yeah, I don't know what that means. Maybe they're just sensationalizing. See, I can see that maybe for 10 stack DB. I could see that for like, yeah, I don't know. Maybe I just lack the way to, yeah, I don't know. I couldn't even describe what I was trying to do. I mean, maybe I'm just not seeing this well enough. I keep feeding elements examples from another framework and then rewrite and remix tree. Then I ask it to compare and contrast to determine which is easier for devs elements to create bug fix and change over time. Maybe it's glazing me, but I get this kind of response every time. If you want a quick sanity check, give a mid-tier LM 2 tasks on each version, blah, 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 blah. So not flattery. My take is that reducing invisible links and specialized lore, that tends to win for approachability and safe edits today. I mean, reading this, so you usually see fewer mistakes and less back and forth on the remix variant because the edit points are obvious and the behavior isn't hidden in the dependency graph. This is interesting because I can get this perspective. He didn't ask it which produces the best results. He didn't ask it what's the most performant. He didn't ask it what will give the best user experience. He asked which one is more likely to, you know, produce the working results to the expectation of the framework, right? So like, you know, we talk about lowest common denominator. Like, can I make my framework dumb enough that anyone, including an LLM, could leverage? And I think this is an interesting quality because this is their pitch, right? This is their thought. They're like, I want to make a framework that works really, really well with LLMs. What does that mean? Well, it means that you can ask it something and it generates the code that works, you know, for it. You know, React is pretty good, but we want to make something better. It says nothing about the quality of what comes out of the other side, right? Like, you could build something that the AI can generate no problem. I mean, this is an interesting hypothesis. If it performed good enough but you could just, you know, easily generate it, this would be an angle because people won't care if it's not the fastest, or like picture a framework that was like React but slower, but it was easier for LLMs to generate. People would probably still use it, right? I mean, you would hope over time that AI would just choose better solutions, or that you could like build better stuff with it. But if you're targeting the lowest common denominator, like if your goal isn't to over time create the best thing, but approach the thing to where it's at today. Actually, you know what it says here? This tends to win for approachability and safe edits, comma, today. He said the AI said today. It even recognizes this might not be the case in the future. But if your goal is to approach what happens today and close that gap, then this makes a lot of sense, right? Right? Like, I remember the Devin creating the to-do MVC app that used God, I forget what component library. It's a really big one, but basically they created like a 300 kilobyte to do MVC app in React and a bunch of stuff, and used all the libraries and stuff. I think if you're okay with that and you can create more like better like things that more represent what you're trying to create, like if it's better at creating what you visualize on screen, there's a lot of people that would like say take a 2 megabyte bundle size for that, you know. Like I'm not saying that you're doomed to fall that way, but I'm just using that as an example, right? Yeah, I mean a little bit, right? Like it's definitely setting the bar pretty low in some ways, but on the other hand, yeah, it's approaching what happens today. Oh, that's an idea. Give the AI all my hack MDs. So I'm just looking at the comments here. Catching up on. Oh, sorry, the Rich Harris thing. Okay, yeah, we'll talk about that in a second. I'll finish up on this one here. AI is fine for CRUD and boilerplate. Funnily enough, Solid will always be better with LLMs than whatever Remix 3 comes out with because Solid has more training presence. I mean, I don't know if that'll always be the case. I mean, I hate when React levels that argument against us, but you wonder if this is a situation where if you're trying to rush approach where things are today and it's a moving target, and for that reason you miss. But yeah, I agree simple and readable code is preferable, but I disagree. Can write simple well, that works. That is bug free. Yeah. This is kind of an interesting question. Call it equals here. I love these questions. The main thing to understand about AI is they're going to be as good as the prompts we give them. Yeah. So I mean that also makes the challenge. But the thing is, the idea is they want to make the prompts like get better at handling the prompts, right? That's essentially the goal here. It's like attacking it from the other vector. I think it's interesting. I just don't know if the result is worth chasing, but like long term, but short term, this might be an angle, right? Is Solid.js stagnating, or is there a future from 2008 watching how things are going? I mean, I feel like if you've watched any of the streams, then you know that, like, I mean, even this stream kind of covered everything, right? From the growth that's happening, the 2.0 changes and features, the how Solid itself core hasn't changed very much, yet has participated in and led in a lot of the innovation that's happened in front end in the last 7 or 8 years. So yeah, I mean, we haven't stagnated, just certain areas. We focused on other areas other than the core reactivity, I'd say, and because we had that mostly right. But yeah, I mean, this is interesting. I really do like opening this kind of thing. Okay, but he just links to the thing about how all this stuff is awkward. Yeah, I mean, it is awkward if your goal. It's interesting. Like, it's the goal to make it as easy as possible to accomplish. I mean, obviously, the goal on a high level is to make it easy as possible to accomplish your goals, right? Like that's the goal high level. But there's a lot of like quality questions that come in between. This is very interesting because this is like the exact opposite way I look at the problem space, which is interesting to me because it starts opening up, the potential of thinking about this, Huh. Honestly, yeah, really interesting stuff. Okay, let's see Rich Harris. This is an interesting balanced research and it confirms my prior, so I'm sharing it. It also makes sense. LLMs speed up your typing part, which feels like the bulk of the job, but it is actually dwarfed by the thinking part, and these things don't think good. Randomized controlled trial to see how much AI coding tools speed up experience open source developers. The results surprised developers thought they were 20% faster with AI tools, but they're actually 19% slower when they had access to AI than when they didn't. Also, participants are OSS devs, library authors, people largely building kind of software that doesn't already exist in training data. If you're building a product app or marketing page, maybe the results are different. But what the study doesn't appear to account for is the time spent weeks later when you're trying to augment or fix code that no one on your team wrote. Me vibe coding. Yes. Me vibe debugging. Yeah. Yeah. I just like, I literally, like, this is the exact counterbalance. This makes sense to me. Whereas this just seems like craziness, but it's sensational. So I don't know. You're either wondering, like, are they just building something like are they building something massive? Like, is this like, are they building Rails? Like, are they building something where they just have so many features that they just need to spit them out, and like typing actually is a consideration? Like, they're just like, we have like this huge feature set, we encompass everything, and that would make a lot of sense. Because like I'm here, like that's interesting. Okay. Okay, so that's it for bookmarks, I think. Okay, yeah, there's one more, but I mean, it's already here. It's for Dominic Ganaway, creator of Inferno, Lexical, main catalyst probably in Svelte runes, and the upgrade to Svelte 5 and fine-grained reactivity. An all-around great guy. We've had him on stream before. I know we talked about this like previous stream, but it's official now. He's leaving Vercel, and he's also hasn't been working on the Svelte team for a couple months now, as we know. So this is the big change, right? The Svelte 5 journey was especially incredible. It was challenging in many ways, but I truly feel the web is a better place because of what we built with Svelte and Svelte Kit. The team behind it is such a talented and friendly group of people. I miss working together. Yeah, but big shift. Yeah, Dominic is not with the Svelte team anymore. He hasn't said what he's doing yet, I believe, but in my world, at least, this is big news. Of course, I've known about it for a little while, but it's official now. So, yeah. As I said, I like it's kind of funny because I remember I was talking. Dominic was working on some of his own prototypes of signals and trying to create this community reacting that signals can be used under the hood, and then he wasn't finding the right place for his work. And then he actually talked to Rich, and they actually like, okay, let's do this. But if Dominic hadn't done that, I wonder if Svelte 5 would exist in the form that it does today. I'm not sure. It's definitely interesting to see the kind of impact people coming and going out of projects can have on those projects. So yeah. Very interested to see what he does next. Okay, I think that's it for bookmarks. I think I have one more topic, probably about, I don't even want to talk about that. Probably about web components. Yeah, here we go. Okay, let's do it. The dividing point between frameworks versus platform purists is the belief of whether DOM should be the source of truth for state. Almost every web component argument issue with design comes back to this. You don't need to go any further than forums to see this in action. The gap between the value attribute, the default value, and the value property already surfaces this tension. When UI equals a function state, there are fewer concepts than even using native APIs. However, using both together correctly ends up being the most involved and easiest to miss certain edge cases. You can see it even with the increment and reset buttons. To be fair, Solid, like most frameworks, already use special cases value as a property unless it is static. And the reason this came about was it's so awesome now to be working with the teams of people. Like, I know I often get credited with a lot of the work on Solid, but we've actually kind of split stuff off into, there's certain people working on fellowships in specific areas, certain people in the core team who have specific specialties, obviously you guys see a lot of the work I do or Dev does more than anything else, because we talk a lot about async models, we talk about events, we talk about concurrency, have expertise in this area. But there's other people on the team who do amazing work. And one of our fellowships, I think of Tito, hopefully I'm pronouncing the name correctly, has been basically taking over DOM expressions in the compiler the last 6 months or so. He was instrumental in the changes in 1.9. So yeah, whenever that was, the web component changes, I guess it's been long, maybe almost a year. And he's been a huge force in updating and standardizing the stuff for 2.0, mostly because he's also a web component guy. And he knew my frustration with dealing with all the edge cases and web components. So he's been looking at the community going, okay, guys, how do we actually do this in a way that's good for web components? How do we make this work in a sensible way? And he managed to come up with a solution that's quite agreeable to me for the most part. He's like, let's get lit of setting properties, default everything to attributes, even on web components, which I always thought was weird. I wanted props on web components, and lit, make things explicit. And all the details of this have been actually great. He also triggered the web components are not the future article, because I was just so frustrated hearing about it. The funny thing is, after that article broke, and he's still a web component guy, don't get me wrong, but after that article broke and he was in there trying to defend, and then he heard the back and forth and he actually worked through the problems and been working DOM expressions, I think his perspective is changed a little bit. Like, he's still, into this stuff, and he understands what the right solutions are. But I saw him get into arguments even with the web component people, being like, you guys are just being kind of crazy. They basically didn't self-identify him in the there. They were like, oh, you're just a Solid guy. But ironically, his impact has actually been fairly substantial. Because if I go here, there is one more story that I missed here. I want to talk about our man Tito here. If I go to my profile, because I've got this blue sky only chain. Justin from Lit went and was like, a while ago, there's a kerfuffle about web components. So he's talking about my article, basically. Frameworks were mad that they had the detective templates contain custom elements so they could switch between clone node and import node. This was one complaint out of dozens that I said I believe is actually a fundamental mismatch, which is what I'm talking about here. But he was saying, but it turns out import node was slower than clone node in Chrome. So frameworks added extra logic to look for elements with dashes in the name to choose import node only for templates to have them. And some blamed web components for messing up the web APIs. Fair enough. Some framework contributors filed bugs against specific new features like is custom so that they could farm this detection logic to browsers, and got really mad when the browser said they shouldn't ever need that. I mean, that wasn't us. Because import node being slower is just a bug in Chrome. See, okay. It was kind of a silly situation, and some people in the web components community filed an issue in Blink and advocate for performance to be fixed. Turns out some kind of navigation heuristic tracking import node, not clone node. So the bug was just fixed. Now import node and clone node have the same performance in Chrome. I'm happy frameworks can get simpler, but also because Lit, which also uses import node, probably got faster too. Filing an issue for browser implement bugs is a good thing for everyone. Okay. Do you know what problem I have with this? How in the world are you supposed to know that this is a bug? Import node does do different stuff than clone node. Otherwise, we wouldn't, why should you even use it? He basically, you should always be using import node. Why? I don't know why. But we know that clearly, if clone node did what import node did, we wouldn't need import node, and we just continue to use clone node. Import node actually adds it to the current document, where clone node does not, which actually has impact on certain types of elements, custom elements, iframes, a bunch of other ones. But so it does more work. It's like saying, should inner HTML and inner text have different performance? Probably. Inner HTML has to parse from markup. Inner text knows that it's just text, right? In fact, text content is faster than inner text for another different reason. In fact, we hit these kind of things all the time when building a framework. Every little detail like this, and we don't question it and go, oh, we just go, okay, well, this seems faster in all the browsers, probably because it's doing less work, right? Simon H, you got this backwards. This problem was fixed only because Solid and Svelte were actively working around it. Look at the reproduction. It's referencing Solid Playground. Thank you. Tito actually created the issue. So just side note. I have no idea what you think is backwards, but you sound like a jerk with this tone. Have fun with that, I guess. Then Dom, I'll talk about Dominic. Yeah, I mean, we can look at this, but yeah, I mean, that's a very good thing. I don't think the complaint was silly. It's just difficult to know if something is fundamentally slow or if it's implementation. Fortunately, Tito, Solid Maintainer reported the issue, now it's fixed. For everyone, for an issue like this, there's a dozen not so easy to address. Also this, yeah. So so Dom's like, your tone's off to start with. I and a bunch of other framework authors have been pushing for this change for a while and been pinging folks at Google as it gets escalated, even when I was on the React team. While you might think it's a silly situation, for those who really care about performance implications here, have strongly aligned that this is a Chrome bug that just needs fixing, as it's not evident in other browser engines. Furthermore, just filing issues is simply not enough. This took a lot of effort for folks to push the issue specifically, so it got noticed and had eyes on so many folks. Tone regarded this should have been different from the start. This was a community effort driven by framework authors who have wanted to address this issue for many years now. This work had nothing to do with web components or lit. That's why the tone is off. Silly issue. There's no issue filed against Chrome at all. The Chrome DOM folk I talked to didn't even know about the problem, so it wasn't widely known or probably even actionable for the DOM team for apparently years. It took urging web components Discord to get anyone to file the issue. Once it was done, there's a visible progress. It's silly that took years to file anyways, but you're welcome, Tristan, blah, 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 blah. I was on this React team, we had early meetings, Chromium folks. Yeah, that's probably true. It got worse in Chrome 125. Yeah. A bunch of times, quicker as I don't summarize it, join it. It's silly. Yeah. I mean, this is a tricky tension here because you can hear it in Justin's tone initially that, we were all just being silly. And yet, like, how do you possibly conclude that? I guess they don't know it's an issue unless someone reports it, but no one's going to report it. They'll just work around it. And unfortunately, no one, probably the real problem was no one knew why web components don't work with clone node in the first place. There's probably a really good reason for it. But like, essentially, this is kind of the realm here of the kind of challenges we come up here with here. And I want to show, I'm going to go back to my thing about DOM holding the state. Because the funny thing is web components encapsulate state in the DOM element, even if, they don't intend to. You're actually encoding that logic, not in, like, instead of having components that output DOM, essentially, you're actually encoding that information into the DOM elements themselves, which is, as I said, fun for things like SSR and serialization considerations when you're dealing with properties. You basically can't serialize props unless you do something specially, whereas attributes are the way. And because of, again, it makes sense, there's a difference between attributes and properties, but having properties is only valuable in places that don't have HTML that, have the DOM, right? Whereas attributes can be used in places that only have HTML. So there is this kind of tension here. And what I wanted to point out here is sometimes the model, let's open all three of these. Sometimes the model is easier without using the native stuff. Because here, for example, this is completely a naive framework approach. We're pushing state. We're like, okay, we have some state, you create signal, use state, doesn't matter what it is. increment it, reset it, driven by framework. So we update to 4 or 5, we hit reset, it goes back to 0 because we set it to 0. This is how people are introduced to this stuff these days because of React, right? It's simple. You drive it off state. The DOM is kind of like an output, right? Like we don't care. It just, we control the state. Now, the naive DOM approach is kind of interesting. I love value as a number as a side note. If you guys aren't aware, it lets you, it basically converts it to a number. Now, the simple framework version should have also had type number. I missed that. But because it lets you do this too, because you'll see why this is relevant. Because this is you setting it via state, right? This is typing into it, essentially. Am I missing something here? Yeah, sorry, you know what I'm missing here? The naive framework, I don't know how did I miss this? Sorry, this is my bad. This is actually my bad. The naive framework version should have had event. This is my bad. Event dot target dot value. Okay, sorry. I don't know how I missed that. That actually probably makes this look way. Okay, now we're better. So this goes up. This. All right. Cast it. Yeah. There we go. Naive framework version. I actually missed that. That is actually on me. Now the state's unified. We reset. Okay. Cool. Okay. No problem. Okay. The naive DOM version actually in a lot of ways is a little bit simpler because it stores the state inside. So when I press plus, what I'm doing here is I'm updating the DOM node directly. And then when I press this, my input is updating. And then when I call reset, I'm actually calling the forms. There's a type reset. I don't know if people know this, but forms also have a type reset, which automatically resets it. So now the state is owned completely by the DOM in this example. So here we have, external state driving it. Here we have the DOM doing it. And arguably, the benefit of this is you don't need event. You only need the event handler on the increment to synchronize. But you did have to know about a button type reset to make it work. But I mean, I think this is reasonable other than it doesn't scale greatly because it's like you can't pull the state out into something else. And then the final version is, and I'm actually missing something here. I just realized. I need to add this. The final version that handles things properly is this version. See if this works. Yeah. Then reset. Yeah. Okay, cool. And the way this one works is this is DOM correct because it's using the reset button. And the thing that isn't obvious here is this is setting the property because we do that by default in Solid. And this one is setting the attribute to make sure that it matches. Because if you didn't have the attribute, the reset wouldn't work because the input has to have the attribute of value is the default value. Technically, I could have also done props default value, but I'm just trying to kind of show that the attribute, like if you weren't overriding it, like made this prop value and make this just value, like if you're trying to inverse it, would have to be like this. And this handles like the full scenario here the proper way. Right. So the reason I'm trying to show this is like state driven, DOM driven, both. Both is definitely the most complicated, right? And the reason this is like a concern is that it's very easy to like not do this quite properly. Let me see if where is it? I'm not seeing it here. And I actually started asking people this because the argument was we should not special case it. Essentially, we should say value is just an attribute, not a property. Like people say they want their framework to behave like plain HTML, yet every major framework except lit special cases value checked and selected as properties, since setting the attribute doesn't update the input, just sets the default for form reset. Right? I gotta admit, this vote was closer than I expected. I expected most people, like wide range. I expected this to be like a 90-10 vote, not like a 57-38. So that is actually interesting. But this is what I'm talking about. If we use attribute to bind when we reset, okay, that worked. I'm trying to remember the case. All right, this is not type number. This will just make my life easier. Yeah, this is a fun one. Because we're binding to the attribute, when we click reset, it doesn't actually, we're changing the default value, not the actual value. So reset now doesn't work properly, which, I mean, that's fine. But more importantly, the state got out of sync. Now, to be fair, I think I should add on input here, because I missed this. But I'm just, the reason I'm going through this is I'm like, picture this is just how value worked by default. So when you did this, oh wait, plus doesn't work. Right? But make it more confusing, plus works initially. But then once I change the value on the input, plus stops working. This would be the default behavior if we bound to attribute instead of to the property. This poll might have been shared on a web Discord or something. Maybe like it's kind of like, picture if this was the default. Like it's kind of crazy. You're like, okay, I'm setting the count. If you're like value and then you're like bound to value. Basically, I think if this is how solid worked by default, people would be like, what, how does this work? Because the proper answer is you tell the end user to use prop.value, right? Because then when you do this, oh, sorry, I gotta plus it again, sorry. Because then it will work the way you expect it to. But just doing the value binding would essentially work like this. Stop working the second you actually change the input. I don't know. I think the reason it's weird is because the value attribute maps to the default attribute value prop, and the value prop doesn't have an attribute. Yeah, but I mean, I was like, this is what I was trying to figure out. Like, people who actually think, like, who in their right mind wants to know that this is how it works? Like, this is way closer than I expected. Lit works like that. Not a single other framework works this way. But the reason we're forced into this is because of, as I said, weird stuff. Like, it's not weird. It makes sense why forms have, let's say, a reset button. But like, picture this one. Like, what if we just said, I mean, I guess we should have no expectation that state doesn't work. Yeah, I mean, I don't even know. This is just, I'm just breaking things at this point. I just like, considering the number of people who like choke on solid using on input instead of on change, I cannot picture the number of people who would choke on being like, on like, oh no, you have to use prop colon value instead of just value here. I like, but this is where things are at. I just kind of wanted to put this out here. There's a bunch of other special cases like values. Like, if you have ranges on inputs, if you set the value before the range, the value doesn't come in like within the range. You have to actually set the ranges, like min and maxes, before you set the value. There's a bunch of special cases that we have to do around inputs anyways. Even before you get to this, we actually pull values out into their own separate binding. They don't get grouped. So like, this is already very like a bit magical to kind of compensate for like weird discrepancies in the DOM. I think this is an interesting touch point, though. As I said, like, this is kind of reflective of where this split is, and I don't know where people sit on this. I mean, clearly more people want to leverage their knowledge of the DOM here, but I can't picture the average developer wanting to like go, oh right, yes, I was setting the attribute, I need to actually use the value property. Now, I found out Vue gets around this a little bit because people use their model, and Angular, they tend to use the models which use property, and if you just use the value directly, it uses the attribute. But obviously we don't have anything like two-way binding, so we're not going to like default to attribute and then switch to property. In fact, Tito's own framework also uses like two-way binding, so most of the time people are using this other syntax, you know. But it seems interesting to me to like, you don't need to know about prop colon for anything else except now you do your first input field, and that's when you have to do it. I don't know. These are the kind of things that keep these communities divided over kind of silly stuff like this, because the framework authors resent having to special case, and even more so for web components. This one, see, we can special case this one because we know the input fields are weird. Like, we just know that. But picture random web component someone makes. We don't know which stuff's weird. That being said, I think in general, other than these special cases, the approach that we're taking in 2.0 of basically defaulting always to attributes unless explicit is probably the most sensible thing. It gets rid of a bunch of extra checks and all these weird, like most of the other weird special casing around web components. And another change that we're proposing for 2.0 is for Booleans to actually require like Boolean values if you want them to show or hide, right? Like the string, like there's a difference between a attribute that takes a true string and an attribute that's a Boolean attribute that hides with false. I think that change in general will be good. We'll have to play with it and see what people think. But sorry, where am I? I think this. It's funny that we've been struggling with this stuff in the web development community for like 15 years now, and it's still, it's interesting that this stuff kind of comes back to head, because this is like in 2010 over special casing value was just the obvious choice, and now it's like, do you want to not special case it and push that responsibility onto your users just to be more consistent, to consider, things like web components? 38% of people think so. So of pollers here think so. So I don't know. It's interesting. Well, because jQuery, because most people aren't thinking about stuff at this level. They just like bind up their stuff. Like, as I said, in a lot of ways, where's the original version? Yeah. This state-driven version is just the most straightforward implementation. Because like a lot of ways, this is the most straightforward actually, sorry, pure DOM thing, but you know that this isn't going to scale with your data set. So the only thing that gets really weird is here, like, it's actually have attribute value 0. I think it's because the default value with that absent, yeah, there's no default value. The reset button doesn't work properly. It sets the count. Huh. So I actually need to put the value on here so that it has something to reset to. So yeah, I mean, it's interesting. Like, you need to use both if you want to, yeah. Even though I'm handling the set, yeah, this is actually interesting because I'm handling the reset event. I wonder if I have to do this. Like, I wonder if the trick here is to do prevent default. And then I don't need it. E dot. I wouldn't say this is working exactly with the on though. Prevent default. Would this fix it? Yeah, there we go. Now I don't need the attribute. But at this point, it's like, why am I even using the reset event? I could literally just put on click on the button. Do you know what I mean? Yeah, the reason I had to do it as attribute here is because value equals 0. Solid actually does make it an attribute when it, like, there's nothing dynamic on it, I guess, which is an inconsistency. But we can't use it because we already have value bound to count. So I mean, that's the argument. It's like, how do you set a default? I guess the whole argument here is how do you, if you don't want to prevent default and you don't have attribute this, because one of the cool things about Tito's PR is that this attribute thing is gone. We don't have it anymore. We just have prop. In order to get this behavior so it doesn't collision, you'd have to do prop default value, I think. And then let's see if that works. Yeah, that works. Of course, you could also just prevent default in the reset. But if you want to use reset, the way the browser intended, you would do this. And honestly, I'm very tempted at this point that we should just support default value as a, like, if you're going to do value, then we have to support default value. I'd rather people go from value and then realize they need default value, I think, than for people to start realizing that they immediately need to do prop.value. And then, yeah. This stuff is just weird, right? Yeah, sorry, I noticed afterwards. I was just saying that, like, for this to work properly, you'd have to, because you have a collision with the value name, you'd have to do like this. We could also just get rid of the prop here for this. I don't believe the namespaces should be used for anything but special cases, which makes it difficult to say that value shouldn't be a prop, because if value is the attribute, what do you call the prop value without using a special case name? Yeah. Anyway, it's a topic. All right. I think that's it for me today. Other than, so what did you share, Fuzzy? Let me see. Can I use CSS attribute? Let me see. Not in Safari or Firefox. Huh. Oh, interesting. I hadn't seen this. Yeah, so it says here to use it for non-string values, including numbers and colors. That's cool. Anyway, I think that's it. The stream today. Yeah. How did we do? We did 5 hours, didn't we? Yeah, 5.5 hours. Okay. Yeah, long one. Thanks for joining me. Again, like the video, or if you can, it definitely helps out. As I said, not streaming this Friday, but September 5th, I should be back. I believe Dylan Piercy from Marco will be joining me to talk about upcoming Marco, which is very exciting. So I've been looking forward to talking about Marco. So hope to see everyone there. You guys all have a great long weekend coming up, and till next time.